In the gypsum flats of southern New Mexico, there is a set of footprints that only shows itself when the ground is holding exactly the right amount of water. Too dry, and the surface closes over them. Too wet, and they flood. But on the right morning, in the right slant of light, the prints rise up out of the white ground as though someone had come through an hour ago, and you can follow them. The researchers who work there call them ghost tracks. They belong to a young woman, or possibly to a lightly built young man. The people who measured them have been careful about that, and they run for 1.5 kilometers in one direction and 1.5 kilometers back. For part of the outward walk, there is a second set of prints alongside, very small, made by a child of about 2. Then the small prints stop. They stop because the child was picked up, and you can see the moment it happened in the way the adult's stride changes. The prints press deeper on one side, the weight settling onto a hip, and they stay that way for a while before shifting across to the other side. Somebody's arms got tired. On the walk back, several hours later, there is no child, which means the child was delivered somewhere, to someone, and that is as much as the ground is willing to say about it. After they had gone, other animals crossed the same trail. A mammoth walked over it without altering its pace. A giant sloth came up to the line of prints and stopped, and you can read the whole movement in the way its tracks splay and turn. It reared onto its hind legs to smell the air where the people had been, then dropped down and moved off. The prints are somewhere between 10 and 13,000 years old, and the range is that wide because it depends on which extinction date you trust for the sloth. It is worth knowing what that place looked like at the time because it was not a desert. A shallow alkaline lake filled the basin, shrinking a little every century, and the flats around its edge were wet grassland and marsh, printed all over by animals that no longer exist. Camels came down to drink. So did mammoths, leaving tracks 0.5 meter across, and ground sloths that stood taller than a person when they rose onto their back legs. So this happened at the tail end of the last ice age, on the bed of a drying lake, in a part of the world our species had reached by a route that nobody can currently agree on. That word is worth being precise about. It does not mean a gap in a museum label, the kind of thing a future dig will quietly fill in. It means the evidence points in 2 directions at once, that the people arguing about it are careful and well-equipped, and that the argument has been running for decades without settling. Over roughly the last 60,000 years, a population that started in Africa walked and sailed and drifted until it had occupied nearly every habitable coastline on Earth. The Australian interior, the Arctic, the high Andes, and eventually islands so small and so far from anything else that finding them at all looks less like exploration than like a mistake in the arithmetic. It is the largest thing our species has ever done. It took something on the order of 2,500 generations, and several of the important turns in it, the crossings and the timings and the routes, are genuinely unexplained. It helps, when the numbers start getting large, to keep hold of the footprints, because whatever else this story is, that walk is its actual unit. One person carrying a child about as far as you would walk to the shops and back, and then walking home. You could put your own foot inside one of those prints. They are not large. The gypsum has held the shape of a 2-year-old's heel for longer than there have been cities, and it will probably hold it a while longer, provided nobody stands on it. The ground at White Sands is unusual in keeping any of this. Most ground does not. Most of what people did across those 60,000 years happened on soft coastlines now lying under 120 meters of seawater, or on surfaces that were rained on a few thousand times and then forgotten entirely. What survives is not necessarily the important part. It is whatever happened to be standing on the right kind of mud, on the right kind of afternoon, and was then left alone for 11,000 years. There is something worth sitting with in that before going any further. We are, as far as anyone can tell, the only animal that has ever gone back to look. Everything else that crossed a continent did the crossing and lost it, the journey surviving, if it survives at all, as a shape left in a bone. We do it, and then 10 or 20 or 50,000 years later, we come back with soft brushes and laser dating and an enormous amount of patience, and we try to work out who these people were and where they thought they were going. Mostly, we fail. And then we come back again the following season. Every animal walks. Almost nothing else has ever turned around to find out where it has been. Before we follow the walking back to where it begins, if you find yourself drawn to these slow walks through deep time, consider subscribing to keep making these journeys with us. And let me know in the comments where you're listening from tonight, your city, your time zone. It's always something to see how far this quiet journey travels, all of us joined by curiosity about the walking that brought us here. Now, let's begin our journey at the start of the walking, with one ordinary afternoon, and then another one, and then 2,500 generations of them. From the western edge of Alaska to the southern tip of Tierra del Fuego is roughly 14,000 kilometers, and there is a reasonable case that people covered the whole of it in something like 1,000 years. Divide one figure by the other, and the number that comes out does not feel like an achievement at all. 10 kilometers a year, a single morning's walk, and then nothing for another 12 months. The figure is soft. It depends entirely on the arrival date, which happens to be one of the loudest arguments in the field, and the range of plausible answers is wide, but the softness barely matters. Push the arrival earlier and the pace gets slower still. Pull it later and it climbs to perhaps 14 kilometers a year, which is not meaningfully different. However that argument settles, the answer sits somewhere between a stroll and a standstill. Nothing about that would have registered as travel. A band of 30 or 40 people moving camp a dozen times a year, following water and game and the turning of the seasons, and finishing each December about 10 kilometers from where the previous December found them, is not going anywhere. It is living. The people in it would have described their year as unremarkable, and they would have been right. Their children did the same thing and ended up 10 kilometers further along, and described their year as unremarkable too. 50 generations of that, and 2 continents are behind them. Almost every map of this ever printed has arrows on it. Long, confident sweeps out of East Africa, across Arabia, fanning through Asia, curling down into Australia, over the top of the Pacific into the Americas. The arrows are not wrong. They describe a real pattern, and the pattern really is that shape. But an arrow is a claim about intention. It has a tail where somebody started and a head where somebody meant to arrive, and it suggests, without ever quite saying so, that the distance between the two was crossed on purpose by people who had some notion of what lay at the far end. Every one of those arrows was drawn afterward, by us, looking backward, already in possession of the ending. Nobody living inside the arrow could see it. There was no frontier either, because a frontier needs somebody on the other side of it to be a frontier from. There was only the country a person had grown up in and could describe in detail, and then, in one direction, country that nobody in the family had walked yet. The word migration carries the same difficulty. It is properly a word for what birds do. An annual navigated movement toward a known destination performed by animals with the route written into them somewhere below the level of thought. Nothing our species did across those 60,000 years resembles that. There was no route to follow, no destination anyone had heard of, and nothing seasonal about any of it. What actually drives the process is duller and far more dependable than ambition. A group of foragers doing well has more children than it buries. Those children grow up, and territory that comfortably fed 30 people is suddenly feeding 45, and the hunting takes longer, and the arguments over it get sharper. At some point, a handful of them, often siblings, often young, usually with their partners, walks a day or two out and settles somewhere with fewer people in it. That is the entire engine. It asks nobody to be brave or curious or restless, though plenty of them surely were. It requires only that human beings have children and dislike being hungry. Run it long enough and it will fill a planet, because there is nothing in it that says stop until it arrives at something it cannot walk across. The whole of it took roughly 2,500 generations. That number is worth holding still for a moment, because it is difficult to feel from the inside. Everything human beings have ever written down, every clay tablet, every scroll, every archive and ledger and letter, the entire span from the first Mesopotamian accounts of grain to this evening, fits comfortably into about 200 generations. The walking took 13 times longer than that and left almost no account of itself whatsoever. It was also done by very few people. Population estimates for this period are rough, and the researchers who produce them tend to say so first and loudest, but through most of that stretch, the entire human species is generally reckoned to have numbered in the low millions, and for long periods, considerably fewer. Every habitable coastline on Earth reached and settled by a population that would not have filled a mid-sized city. You are the far end of that, not as a figure of speech, the actual far end. Every single person in that chain of 2,500 lived long enough to have children who lived long enough to have children, which is a run of luck so improbably long that it stops behaving like luck and starts behaving like a law. The model is clean, it explains most of what happened, and it is almost certainly right about most of what happened. The genuinely interesting thing is where it stops working. It has no mechanism, for one, for open water. A gentle outward pressure of people who dislike being hungry does not place anyone 90 kilometers out to sea with no land visible in any direction, and it certainly does not do so repeatedly enough or successfully enough to found a continent. Somewhere in the islands north of Australia, somebody made a decision, and there is nothing in the arithmetic of children and hunger that can tell us what it was. The date of that arrival has refused to settle for 9 years now, with the archaeology insisting on 65,000 years, the genetics arguing for rather less, and then partly changing its mind, and both camps being careful and neither being obviously wrong. Nor does anything in the model account for a kind of human being who has left, so far, almost no bones anywhere on Earth, and who is nonetheless present in measurable quantity in the bodies of people alive tonight in the Philippines, in New Guinea, in Northern Australia. And it has nothing whatever to offer about the thread of ancestry running through communities in the Amazon and along the Pacific coast of South America that points unmistakably to the far side of the world, with no route, no carrier population, and no proposed voyage that anyone has yet made stick. Somewhere in that chain of 2,500 is the woman on the wet flats in New Mexico, moving a 2-year-old from one hip to the other. She had a name. So did whoever she handed the child to at the far end of the walk, and so did the child. Not one of those names survives, and none of them ever will, and the loss is so complete that it does not even register as loss. There is no gap where they ought to be, because nothing ever recorded that there was anything to record. What survived instead was the walk. Not her name, but the fact that she was tired, and which way she was heading, and that the child was heavy. Which leaves something worth turning over. If the process really is as automatic as it looks, if it needs nothing more than children and hunger and enough time, then it ought to have worked every time it started. It started more than once. Most of the time it did not work at all. There is a kind of absence in the fossil record that takes a while to notice, because an absence does not announce itself. It is this. Of all the people known to have left Africa before roughly 50,000 years ago, and there were a great many of them, spread across well over 100,000 years, not one has a living descendant anywhere on Earth. They are not scarce in the ground. Their bones turn up in caves along the eastern Mediterranean in reasonable numbers, decently preserved, carefully excavated, argued over for decades. What is missing is the other end of them. No thread runs forward from any of those people to anybody now. The oldest is a piece of upper jaw from Mislia Cave on the western slope of Mount Carmel in what is now Israel, somewhere between 177 and 194,000 years old. That makes it the earliest modern human found outside Africa by an enormous margin. It is a fragment, a maxilla with most of its teeth still seated in it, and the person it belonged to was anatomically no different from anyone alive today. Later, and not far away, there are the caves at School on the same limestone ridge, and at Kafse in the hills above Nazareth. Somewhere between 90 and 120,000 years ago, people were living in both of them and burying their dead in the floor. At Kafse, one grave holds a child of about 13, laid in a pit cut into the cave floor, with the antlers of a deer placed across the chest and the hands arranged to hold them. At School, a man was buried with the lower jaw of a wild boar in his arms. There is red ochre through those layers. There are seashells carried up from the coast with holes bored through them, several still showing traces of pigment, which means somebody was stringing them and wearing them. You would have recognized everything about these people. The care is not ambiguous. Nobody digs a pit and arranges antlers on a child by accident, and nobody carries shells inland for 20 kilometers because they were convenient. This is grief and ornament and ceremony 90,000 years ago in caves that are still standing and that anyone can walk into on a Tuesday afternoon. And nothing came down from them, not a lineage, not a fragment, nothing that anyone has been able to find in a living genome. Whatever those families were, they ended somewhere in the following 20 or 30,000 years, and the ending appears to have been complete. What actually happened is unknown, and the honest version of that answer is short. The caves themselves suggest the shape of it without explaining it. Modern humans at School and Kafse around 100,000 years ago. Then, in the same region, and in some cases the neighbouring valleys, Neanderthals at Kabara and at Amud from roughly 70,000 years. Then modern humans again, much later. The corridor swung back and forth. Something about that stretch of coast in that period would sustain one population and then the other, and whether the switching was driven by climate or by competition or by nothing more dramatic than bad demographic luck in groups small enough that a run of hard decades could finish them, the evidence as it stands cannot tell those possibilities apart. So the departure we descend from looks a little different in that light. It was not the first attempt, and it was almost certainly not the 10th. What separates it from the others is not that the people involved were better equipped or braver or working from some new idea about the world. As far as anyone can determine, the only difference is that this one kept going. The era of departures that ended runs from Mislia through Kafze and beyond. Something close to 100,000 years of people walking out of Africa and not lasting. The successful one has so far managed about 60. The failures had the longer run. The same pattern turns out to hold inside the successful line, which is where it becomes genuinely strange. In December of 2024, a team working on the oldest modern human genomes ever recovered published results from 2 sites in Central Europe, a cave at Ranis in Germany and a cave system in Czechia called Zlatý Kůň, the Golden Horse. The remains are around 45,000 years old. When the genomes were compared, the woman from the Golden Horse and 2 of the individuals from Ranis turned out to be 5th or 6th degree relatives. In ordinary terms, something close to second cousins. 2 caves a couple of 100 kilometers apart, and the people in them were relations. Those same genomes settled an argument that had been running for years. Everyone alive outside Africa carries a small amount of Neanderthal ancestry, somewhere between 1 and 2%, and the question had been whether it accumulated through many separate meetings over many thousands of years, or arrived in something more concentrated. The Rani's genomes are old enough and near enough to the source that the Neanderthal stretches inside them are still long and unbroken, not yet chopped into fragments by the reshuffling that happens in every generation. The length of those stretches works as a clock. Measure them, and the answer is a single episode of mixing somewhere between about 49 and 45,000 years ago, shared by every non-African population that has ever been tested. A few centuries of contact in one region between populations that were probably small are walking around this evening in the bodies of roughly 7 billion people. And the families at Ranis and the Golden Horse, the oldest modern human genomes anyone has recovered, members of the founding population related to one another closely enough to have met at a wedding, left no descendants either. Their branch stopped as thoroughly as the ones on Mount Carmel did. They represent the deepest split we know of from the line that worked, and they are still a dead end. There is one further thing the genetics is reasonably clear about. Every person alive outside Africa traces their maternal line, mother to mother to mother without a break, to one of 2 lineages, and both of those descend in turn from a single lineage in Africa. The whole of the non-African world runs back through an opening that narrow. None of which reflects badly on anyone. The families at Kafze were not doing anything wrong. They buried their dead with more ceremony than a good many later societies managed. They lived in that cave across a span longer than recorded history. And the reason their line is not here has nothing to do with them. Lines are thin. The odds are long. Nothing was ever owed. All of this sits badly against something on the other side of the world. If everyone outside Africa carries that Neanderthal ancestry from one meeting between 49 and 45,000 years ago, and Aboriginal Australians carry it in the same proportion as everybody else, then no ancestral line can have left that meeting much before it took place. And yet somewhere around 65,000 years ago, according to sand that has been dated and redated and fought over ever since, somebody was grinding ochre in a rock shelter in Arnhem Land, on the far side of a sea that has never once, in the whole history of our species, been dry. The interesting question about that sea is not how anybody crossed it. Boats are old, people are resourceful, and a bamboo raft lashed with rattan will carry a family a considerable distance in settled weather. The harder question is why anybody pushed off at all. What makes a person leave a shoreline they know deliberately, heading for somewhere there is no evidence exists? The water in question has a name and a discoverer. In the middle of the 1850s, a naturalist named Alfred Russel Wallace was working his way through the islands of what is now Indonesia, collecting beetles and bird skins to fund the trip, when he noticed something that made no sense to him. Bali and Lombok sit about 35 kilometers apart. On a clear day, each is plainly visible from the other, and a sailing boat can cross between them in a morning. The animals on them have almost nothing in common. Bali has woodpeckers and barbets and the ordinary run of Asian forest birds. Lombok, that same morning's sail away, has cockatoos and honey-eaters, which are Australian. Wallace could stand on one beach and look across open water at another continent's wildlife. The reason is depth. Sea level has risen and fallen by more than 100 meters repeatedly over the last few million years, and when it falls, the shallow shelves drain. Sumatra, Java, and Borneo become part of mainland Asia, and it is possible to walk between them. Australia, New Guinea and Tasmania merge into one continent. Between those two shelves, though, the water is deep, trenches that stay flooded no matter how much of the ocean the ice caps take up. Geologists call the western shelf Sunda and the eastern one Sahul, and the band of islands in the middle, the ones Wallace was walking across, is Wallacea. It has never been joined to either side. What that meant in practice is that for millions of years almost nothing got across. Elephants did not. Neither did tigers, rhinoceroses, leopards, or any of the monkeys. On the eastern side, the marsupials stayed where they were. A few things managed it: rodents riding rafts of storm-torn vegetation, bats that could simply fly, and a line of stubby elephant relatives called stegodons that appear to have swum, since proboscideans are far better swimmers than they look. But the rule held for an extraordinarily long time. The water sorted the world into halves and kept them sorted. Which raises the obvious possibility about people. If a stegodon can swim and a rat can float, perhaps nobody decided anything at all. Perhaps a storm took a fishing party out one afternoon and the current did the rest. That idea has been tested properly, and it does not survive the testing. A group led by Michael Bird ran ocean drift simulations against reconstructed coastlines and sea levels, then asked how frequently people would need to be swept off Wallacean beaches for accident alone to deliver anyone to Sahul. The probability stays under 5% unless the model assumes that at least 40 adults are washed out to sea and survive long enough to make landfall once every 20 years, repeated dependably for as long as it takes. That is not an accident. That is a catastrophe on a schedule. It also has to produce more than a single arrival. Separate modelling of the minimum population required to found a group that will not simply die out on an empty continent has produced figures in the high hundreds to low thousands, arriving either together, which is a great many rafts, or in batches across generations, which requires the accident to keep repeating in the same direction. Then the same study changed one variable, and the result is the reason people still discuss it. In place of pure drift, the voyagers were given two things: a choice about when to leave and the ability to make headway toward a destination at half a knot. Half a knot is not a speed anyone would notice. It is a little under 1 kilometer an hour, slower than a person walks down a corridor, slow enough that a hand trailed over the side would feel almost no pull. On most small craft, it sits close to the minimum at which steering does anything at all, the threshold below which a paddle or a steering oar stops mattering, and the vessel simply goes where the water is already going. It is the difference between floating and going somewhere. In about the smallest quantity that difference comes in. With those two adjustments, the crossing stops being a lottery. It becomes not merely possible but likely and repeatable, and the sort of thing a population could do on purpose more than once. Which is the real finding, and it is not a modest one. By at least 50,000 years ago, and plausibly a good deal earlier, people could plan a voyage lasting several days, wait for the right conditions, and hold a heading. Where they did it is still argued about, and the teams doing the modelling have reached different answers. The southern route runs from Timor or from Roti just beneath it, directly across to the northwestern shelf of Sahul. One long crossing of somewhere around 90 kilometers, give or take whatever the sea level was doing that century. The northern route goes the other way entirely, up through Sulawesi and out along the chain of the Moluccas, past Buru and Seram and Halmahera, and down onto Misul, which at the time was simply part of the Sahul mainland. Many more crossings, each of them far shorter. The difference between them is not distance, it is what can be seen. Reconstruct the sight lines along the northern chain, and the next island is visible from the last at every stage. Low, hazy, sometimes no more than a thickening on the horizon, but present, Anyone on that route is never out of sight of the land they are aiming at. The southern route is not like that. Every leg but one has a visible target. The final leg does not. That is not quite the same as sailing toward nothing, which is worth being careful about, because an empty horizon can still carry a great deal of information. Australia burns, and burned then, seasonally and on a continental scale, and smoke from a fire front rises high enough to be seen from a very long way offshore. Cloud behaves differently over land than over open water. It gathers and holds above a warm coastline in a way that Pacific navigators were still reading within living memory. Birds go out in the morning and come back in the evening, and the bearing they return on is a statement about where the land is. None of those signs tells anyone what is out there, how large it might be, or whether it can be landed on at all. They say only that the water does not continue forever in that direction, which may well have been enough. It is worth standing on that beach for a moment on the morning it happened. The raft is bamboo, or something close to it, lashed and floated and tried out in the shallows. There are perhaps a dozen of you, perhaps 20, with fresh water sealed into lengths of cane and food for 4 or 5 days. The weather has been watched for a week, and somebody has decided that today is the day. Through the first afternoon, the island behind you is still there, getting lower each time anyone looks back. By the second morning, it is a grey line that might be cloud. Then it goes, and you are on open water with nothing astern and nothing ahead for a day, and then another day, holding a course that cannot be checked against anything, toward a country inferred from smoke. They kept going. That is the entire content of what the evidence tells us, and it is not a small thing to know about people. Somewhere out there on the second or third day, with the last island gone under and no new one showing, a group of human beings decided not to turn around and were right. Whatever they came ashore onto is no longer there. The sea rose afterward and took that coastline, along with nearly everything that happened on it. A long way inland from where the shore once ran, beneath a slab of sandstone that has been shedding monsoon rain for longer than our species has existed. The sand underneath kept something. In the dry season of 2015, in a square hole cut carefully into the floor of a rock shelter in Western Arnhem Land, somebody lifted a small piece of red stone out of the sand and turned it over. It was ochre. Iron-rich rock, the pigment that has been in use on that continent for as long as there have been people on it. What made this particular piece worth stopping over was its shape. One end had been worn down to a flat, smooth facet, set at an angle, in exactly the way the tip of a pencil goes when someone has been pressing it against a surface and turning it slightly as they work. You have produced that shape yourself, probably within the last year. It is what happens to soft material when a hand holds it at a consistent angle and rubs. The sand it came out of has been dated repeatedly and by more than one method to somewhere around 65,000 years ago. There is no way to know what the person was doing. Ochre gets used for painting skin and painting stone, for mixing into resin as an adhesive, for treating hide, for preserving things, for marking objects that matter to somebody. The wear tells us about the gesture and nothing else. Held, angled, pressed, worked back and forth against something until it flattened. The shelter is called Majed Bebe, and it sits at the foot of a sandstone outlier of the Great Escarpment that runs through this part of the Northern Territory. It is a sensible place to stop. The overhang is deep enough to keep the monsoon off, there is water nearby, and a floodplain within an easy walk fills seasonally with birds and fish. People have been stopping there ever since. The country is Mirarr country. The Mirarr are its traditional owners, and the excavation that produced the ochre was theirs, carried out at their invitation, under their control, with senior traditional owners present throughout, and under an agreement that everything recovered would remain on country rather than travelling south to a museum. That is not how archaeology in Australia was conducted for most of the 20th century. and the difference is worth registering. The shelter had been dug before. Johann Kaminger opened a trench there in 1973, when the site was still being recorded under a different name. In 1989, Rhys Jones and Bert Roberts came back and applied a dating technique that was then fairly new and returned an age of somewhere between 50 and 60,000 years. That caused considerable argument at the time, being a good deal older than most people had been expecting. Chris Clarkson's team reopened the site in 2012 and again in 2015 with better methods and far more of them. At around 2.5 meters down, in a dense band of occupation, they recovered over 10,000 artifacts. Among them were fragments of hatchets with ground edges, axe heads whose working surfaces had been abraded smooth rather than simply flaked, which takes a great deal of patience and produces a substantially better tool. Nothing of that kind has been found anywhere else in the world at a comparable age. There were grindstones with residue still sitting on their surfaces, used for processing seeds and other plant material, tens of thousands of years before grinding technology was supposed to have appeared anywhere. And there was ochre in quantity, around 100 pieces of it showing signs of having been ground, alongside mica-rich material that gives a reflective quality when applied, which is difficult to account for as anything other than decorative. Later analysis of the plant remains from those layers turned up the residue of a broad diet: pandanus nuts, palm stem, fruit, roots, and tubers. Several of the species involved cannot be eaten as they are. They have to be leached or pounded or roasted or otherwise dealt with, or they will do nothing but make a person very ill. So by the time those layers were laid down, somebody had already established which plants on an entirely unfamiliar continent were dangerous and what could be done about the ones that were nearly edible. That knowledge carries a price. It is not acquired from a distance. The date itself comes from the sand rather than from anything lying in it. When a grain of quartz sits in sunlight, whatever energy it has been storing is wiped clean. Bury it, and it starts accumulating again, absorbing a slow trickle of natural radiation from the surrounding sediment and trapping that energy in flaws in its crystal lattice. Take the grain out again in a darkened laboratory, hit it with light, and it releases everything it has been holding as a faint, measurable glow. The brighter the glow, the longer since that grain last saw the sun. The refinement that matters here is that the measuring was done one grain at a time. Zenobia Jacobs and her colleagues at Wollongong ran tens of thousands of individual quartz grains, rather than measuring bulk sediment and averaging the result, and the distinction is worth spelling out because it is the whole argument in miniature. A bulk measurement produces one number and conceals everything behind it. Measure grains separately and the spread becomes visible. If a layer has been churned, if grains from higher up have worked their way down over the millennia, the spread gives it away, because disturbed sediment produces a wide scatter of wildly different ages. Sediment that has been left alone produces a tight cluster. The clusters at the base of the shelter were tight. They gave an age for the lowest dense occupation of 65,000 years, plus or minus 6,000. That plus or minus is not ornamental. The team published the figure and published the uncertainty alongside it, which is what the range is for. On their own accounting, the true value sits somewhere between roughly 59 and 71,000 years, and the midpoint is the number that went into the headlines. They also set out at length what they had done to test whether the deposit was intact, because they understood perfectly well that this would be the first thing anyone asked them. They were right about that. The paper appeared in Nature on the 20th of July, 2017, and it has been contested more or less continuously since. Not by cranks and not on grounds that anybody could wave away, but by careful researchers with a specific and serious objection concerning what happens to small hard objects lying in soft sand across a very long stretch of time, which is how a piece of ochre with a flat spot worn into one end came to sit at the centre of the longest-running argument in Australian archaeology, and one of the more consequential arguments anywhere in the study of our own species. Because if the shelter is right, then the account of how everyone outside Africa is related to everyone else has a hole in it about 20,000 years across. There are 3 clocks running on this question, and they return 3 answers. The sand in the shelter says 65,000 years. The mitochondrial DNA of living Aboriginal Australians and Papuans, as of a study published at the very end of November 2025, says around 60,000, which was a change of position, since for years the genetic estimates had clustered closer to 47. A third method, working from an entirely different part of the genome, comes out near 40,000 and shows no sign of moving. Nobody producing those numbers is being careless. They all publish their uncertainties. Several have spent 30 years on the problem, and the closer the disagreement is examined, the more reasonable each side looks. The spread between the highest and lowest figures is around 25,000 years, which means the error bar on when people reached Australia is roughly 5 times longer than the entire history of writing. The objection to the shelter has nothing to do with the dating technique, which is sound and was applied with unusual care. It concerns a distinction that sounds pedantic for about 10 seconds and then stops sounding pedantic at all. Single-grain luminescence tells you when a grain of quartz was last exposed to sunlight. It gives you the age of the sand. It does not give you the age of the stone axe lying in the sand. Those are the same number only if the axe has stayed precisely where it was set down, and sand is a poor material for holding things still. Anyone who has kept a jar of rice with something heavier buried in it knows the mechanism. Disturb the jar now and then across a long enough period, and the dense object works its way downward, while the grains around it stay more or less where they were. In a rock shelter, the disturbance comes from rainfall, from roots, from animals digging, and above all, in northern Australia, from termites, which shift sediment on a scale that is genuinely difficult to overstate. Jim Allen and James O'Connell have been pressing this argument in one form or another for the better part of 2 decades. Their position is that the artifacts at the base of the shelter are younger than the sand surrounding them, and that the real figure for the site and for the continent sits nearer 50,000 years. A 2020 analysis raised termite activity specifically as a process capable of moving material downward without leaving the sand disturbed enough to register in the grain ages. The excavator's reply is that the grain age clusters at the bottom are tight rather than scattered, that the density of material in that layer is extremely high, and that a deposit churned by termites ought to look churned, all of which is true. The counter-reply is that sand grains and stone flakes are different sizes and different weights and are under no obligation to travel together, which is also true. The genetic approach comes at the problem from the opposite end. A team based largely in Huddersfield and Pavia assembled 2,456 complete mitochondrial genomes from Australia, New Guinea and the Western Pacific, close to 1,000 of them newly sequenced, by a wide margin the largest such dataset ever put together for the region. Mitochondrial DNA descends the maternal line without reshuffling, which makes it unusually straightforward to build a tree from. Count the mutations separating 2 branches, divide by the rate at which mutations accumulate, and the arithmetic returns a time since those branches parted. The maternal lineages that exist only in Australia and New Guinea, found nowhere else on the planet, turn out on that reckoning to have separated from their nearest relatives somewhere between 60 and 63,000 years ago. The same analysis supported 2 entry routes rather than one, a northern and a southern, arriving at approximately the same time. And then, in the section of the paper that gets read least and matters most, the authors set out what their result is not. Ancient DNA recovery in Australia has been poor across the entire continent and the whole of its prehistory. Exactly one prehistoric mitochondrial genome has ever been successfully retrieved. Everything else is inference from the DNA of living people, run backward through a molecular clock whose calibration is itself contested. The placement of the southern root lineages on the tree is described in their own text as tentative. The modern populations sampled are unlikely to reflect where their ancestors actually lived, and the nuclear genome method, which these authors dispute, goes on returning an answer near 40,000. Underneath all of it sits the harder problem. Everyone outside Africa carries Neanderthal ancestry from one episode of mixing now dated to between about 49 and 45,000 years ago, and Aboriginal Australians carry it in the same proportion as everyone else. If that dating holds, no ancestral line can have separated from the rest of humanity much before the meeting happened, and an arrival in Australia at 65,000 years, or even 60, leaves nowhere for the meeting to have occurred. Something in that chain is wrong. At present, nobody can say which link. It is worth setting the argument down and going somewhere the dates are not in dispute. The better part of 3,000 kilometres south, in far western New South Wales, there is a system of lakes that has been dry for around 15,000 years. Along the eastern shore of each one runs a lunette, a long crescent of dune built up by the prevailing wind off the water while the lakes were still full. In 1968, a geologist named Jim Bowler was working his way along one of those dunes, reading the sediment for what it could tell him about past climate, when he noticed burnt bone weathering out of the sand. What he had found, and what was excavated the following year, was a woman. She had been cremated. After the fire, her bones were deliberately broken up, and the fragments burned a second time, and then gathered together and buried in a small depression in the ground. That sequence, burn, break, burn again, bury, is the oldest known cremation anywhere on Earth, at roughly 40 to 42,000 years old, which makes it something slightly larger than the oldest cremation. It is the earliest surviving evidence of a procedure, of people having a set of steps for the dead and following them in order, because that was how it was done. 6 years later, a few hundred meters away, Bowler found a second burial. A man, laid out full length, hands folded together in his lap and covered in red ochre, whose nearest source lies at least 200 kilometers away. Somebody carried that pigment across that distance for this. They are known as Mungo Lady and Mungo Man, and if you go to the Willandra now, you can stand at the lunette on a surface that looks like the least plausible spot on the continent for anyone to have lived. Dust, low scrub, wind. When those burials were made, it was a lake with fish in it and freshwater mussels and birds enough to keep a community fed. Mungo Lady was returned to the Willandra in 1992 and kept in a locked safe on site with 2 keys, one held by Aboriginal elders and one by the park. Mungo Man spent over 40 years in institutional collections in Canberra before being driven home to country in 2017, with people standing along the road as he came in. What should happen to them since has been the subject of long and genuinely difficult discussion among the 3 traditional owner groups of the Willandra, the Barkinji, the Ngiyampaa and the Muti Muti, and it is not a question outsiders are owed an opinion on. For the argument about arrival, the Willandra matters because nobody contests it. 2 burials, dated by several methods, in sediment nobody suspects of shifting, with no possibility that a body worked its way downward through the sand. And at 40,000 years, these people were 1,000 kilometers from the nearest coast, deep in the interior, running a lake margin economy, moving pigment across 200 kilometers of country, and conducting funerals with multiple stages. None of that resembles arrival. It resembles having lived somewhere a very long time. Precisely how long is the whole question, and the Willandra cannot answer it. But there is something about both places worth noticing, and it may matter more than any of the dates. The shelter in Arnhem Land is far inland. The Willandra is further inland still. Both survive because they sit high and dry and the sea has never reached them. Nobody arriving by boat lands in the middle of a continent. They come ashore on a coast and they stay near it because that is where the food is. The first several thousand years of human life in Australia happened along a shoreline, and that shoreline has been underwater for a very long time, which leaves a question sitting over every figure argued about in this chapter. If the sites we are fighting over are simply the ones that happen to be high enough to survive, what was standing on the ones that weren't? Start with a single point on the water, somewhere off the northwest coast of Australia, 300 kilometers out from Broome, on a morning with no swell in it. There is nothing to look at. The Timor Sea from the deck of a boat looks the way any tropical sea looks, flat, hot, an implausible blue and completely without incident. The water underneath you is around 50 meters deep, which for an ocean is almost nothing. Drop a line and it finds sand. 50,000 years ago you would have been standing on that sand. Not on a beach either, a very long way from any beach, somewhere near the middle of a country, and it keeps going. Move the boat another 100 kilometers to the northwest and the floor is still there, still shallow, still sand, another 100 and another. The shelf off northwestern Australia runs out toward Timor for roughly 500 kilometers before the bottom finally falls away into real ocean, and for most of the last 60,000 years every meter of it was dry ground with things living on it. Its shape has been reconstructed in some detail, largely from seafloor mapping carried out for entirely unrelated reasons: oil survey, hydrography, fisheries work, which turns out to preserve a drowned surface remarkably well. It was not a featureless plain. The rivers of the Kimberley and Arnhem Land, which now reach the sea within a few kilometers of where they rise, once ran on for hundreds more and cut valleys across it. There were freshwater lakes. For a long period there was a large inland sea sitting in a basin in the middle of the plain and connecting to the ocean only intermittently. Toward the end, as the water came up, the high ground broke apart into an archipelago, hundreds of islands where there had recently been continuous country. Estimates of how much land Australia lost as the sea returned run to something around 2 million square kilometers, an area larger than Mexico. That land was not marginal leftovers. It was coastal plain, river mouth, estuary, and wetland, which is to say the most productive country on the continent, the places with the most water, the most food, and the highest concentration of people. The 2023 study that mapped the northwestern shelf in the greatest detail, led by Casey Norman, ran habitability models across the reconstructed surface and concluded that at various points across the last 65,000 years, it could have supported somewhere between 50,000 and 500,000 people. Estimates for the total population of Australia before colonisation are contested and range widely, but if the shelf ever came close to its modelled maximum, then a substantial share of everyone who ever lived on that continent lived on ground that is now seabed. The drowning was not gradual, or not evenly so. Sea level rose about 125 metres between the depth of the last ice age and around 7,000 years ago, but it did not rise steadily. It came in surges, and two of them did most of the work here. One between roughly 14,500 and 14,000 years ago, another between 12,000 and 9,000. Together, they put about half the northwestern shelf underwater. On ground that flat, a small vertical change buys an enormous horizontal one. A rise of 1 meter, across a slope of 1 in 1,000, moves the shoreline a kilometer inland. During the fastest phases, the sea was climbing at something on the order of a few centimeters a year, which sounds like nothing at all and is nothing until it is set against the length of a life. Somebody born at the start of one of those surges and living 70 years would have seen the water come up by 2 or 3 meters. In country that flat, that is a shoreline several kilometers further inland than the one they were born on. It was not a catastrophe, nobody drowned in it. It was a slow, continuous, entirely unmistakable retreat. The camp your grandparents used is underwater now. The place your parents were born is a sandbank, and you move, and your children move, and their children move, and nobody anywhere in that sequence experiences it as more than the world being slightly smaller than it was. That this kind of material survives at all and can be got back was demonstrated on the other side of the planet almost a century ago. In September of 1931, a trawler called the Kilometer was working the Lehman and Oa banks, some 40 kilometers off the Norfolk coast in the North Sea, when the net came up carrying a lump of peat. The skipper broke it open and found a barbed point of red deer antler inside, a harpoon, carefully made, of a type used by hunters across northern Europe at the close of the last ice age. It had come up from beneath 40 meters of water. What that lump of peat established, and what took decades to be properly accepted, is that the floor of the North Sea is a drowned country. Doggerland, as it came to be called, joined Britain to the European mainland and was lived on for thousands of years, and trawlers have been bringing pieces of it up ever since. Mammoth teeth, aurochs bone, worked flint, and now and then human remains. Australia had nothing comparable until remarkably recently. Then, in 2019, a team diving off Murujuga on the Pilbara coast, the Dampier archipelago, which carries the greatest concentration of rock engravings anywhere on Earth, found stone artifacts lying on the seabed. In one channel, at Cape Bruguières, they recovered 269 of them from water up to about 2.5 meters deep. At Flying Foam Passage, they found a single artifact at 14 meters beside a submerged freshwater spring. The shallow site is at least 7,000 years old, the deeper one at least 8.5. Those are modest numbers at modest depths, and the point is not the size of the haul. The point is that it worked. The material is down there, it can be located, it can be brought up, and until 2019, not one underwater archaeological site had been confirmed anywhere in Australia. All of which puts the argument about arrival dates in an awkward light. Every site in that dispute is an inland site. The shelter beneath the sandstone, the burials in the dry lake bed, every location where the numbers are being fought over. They survive because they sit high. What we are working from is a map with the middle torn out, and we are dating the edges with enormous care and calling the answer an arrival. There is no name for the country that was there, none that anyone wrote down and none that came through the drowning of it, though there were certainly names. Several 100,000 people do not live somewhere across 50,000 years without naming the rivers. Somewhere under the Timor Sea, beneath 50 meters of warm water and a few meters of sediment, there is a river valley whose name has not been spoken in 9,000 years and a lakeshore where people camped for longer than the entire subsequent history of our species. It is not lost, exactly. It is out of reach, which is a different condition and in some ways an easier one to sit with. Everything that place ever was is still down there. Nobody threw any of it away. The sea took the low ground wherever it could reach, and the low ground was where people lived. But water only climbs so far. Back across the strait, north along the islands they had come down through, there is a belt of limestone standing well above anything the ocean has managed in several million years. Towers of it, hollowed out into caves, holding air that has stayed dry since before any of this started. On the wall of one of those caves, somebody left something that nobody was expecting to find. On the wall of a limestone cave in southern Sulawesi, there is a painting of a pig and 3 human-like figures, and it is at least 51,200 years old. That makes it the oldest known figurative art anywhere on Earth, and the oldest known narrative scene, the earliest surviving instance of somebody depicting an event rather than a thing. It is roughly 15,000 years older than the paintings at Chauvet in southern France, which held the record for a long while. 15,000 years is longer than the entire span since the last ice age ended. The cave is called Leang Karampuang, and it sits in a belt of limestone towers north of Makassar, forested and honeycombed with hollows. The panel is small and in poor condition, because tropical limestone sheds its surface continuously, and most of the paint has gone with it. What survives is a pig, standing, its mouth slightly open, worked in a dark red mineral pigment. Around it are 3 figures with human proportions. One appears to hold a rod of some kind against the animal's throat. Another is positioned head downward near its face with the legs splayed. A third has an object near the pig's head. Whether those figures are people or something more complicated than people is arguable. Several images in the neighboring caves are part human and part animal, a category that turns up across the world in wildly separated periods. What is not arguable is that something is happening in the picture. There is more than one participant. There is an object. There is an action being carried out on an animal shown as alive. Nobody paints that in order to record what a pig looks like. The date comes from the wall rather than the paint, and how it works explains why the number keeps traveling in one direction. Water moves through limestone constantly, carrying dissolved calcium carbonate, and where it seeps across a cave wall, it lays down a thin, translucent crust in layers. The same material stalactites are built from. Where that crust has grown over a painting, the painting has to be older than the crust. Measure the decay of uranium into thorium within the calcite, and you get an age for the mineral, which gives a minimum age for whatever lies beneath it. That word minimum carries an enormous amount of weight. The crust does not start forming the moment the paint dries. It might begin in a decade or in 5,000 years. Every date produced this way is a flaw rather than a measurement. The painting is at least this old, maybe considerably older, and no available method will currently say by how much. Until recently, the crust had to be drilled out and dissolved, which meant averaging across its whole thickness. The layer closest to the paint is the oldest, the outer layer the youngest, and averaging them pulls the answer too young. The 2024 study used a laser instead, vaporizing microscopic quantities of calcite in sequence and dating the innermost layer specifically. Applied to a hunting scene in a nearby cave that had already been dated to around 44,000 years, the new approach pushed it back to at least 48. Applied here, it returned 51,200. 3 years earlier, in a valley in the same karst, reachable only on foot through a narrow passage, the same group had recorded a life-sized painting of a Sulawesi warty pig, a stocky animal with facial warts, still living on the island, with 2 hand stencils above its hindquarters. That one came back at a minimum of 45,500 years. People in the nearby village had always known it was there. It had simply never been recorded. Which is the part of all this worth sitting with, and it has very little to do with pigs. The account most of us absorbed somewhere is that art begins in Europe. Around 40,000 years ago, in the caves of France and northern Spain, people start painting, and the arrival of symbolic behavior in that region has been treated for over a century as the moment our species became fully itself. There is a name for it in the literature, and a considerable body of theory has been built on the premise that something changed cognitively in Europe. The Sulawesi paintings were never hidden. Dutch archaeologists were recording hand stencils in these caves in the 1950s, and local communities had known about them for very much longer. They were assumed to be recent, a few thousand years at most, because everyone was confident that tropical weathering destroyed anything older, and because the framework said the old material was elsewhere. Nobody dated them, because there seemed no particular reason to. When somebody finally did in 2014, the stencils came back at around 40,000 years, the same age as the oldest European work and older than nearly all of it. The paint had been on those walls the entire time. What changed was not the evidence, but the assumption about where it was worth looking, and the story of art beginning in Europe turns out to be a fossil of where 20th century archaeologists happen to be standing. There is a second thing about these islands, and it complicates matters further. Modern humans were not the first ones on them. On Sulawesi, at a site called Talipu, there are stone tools in dated sediments at least 118,000 years old and possibly nearer 200,000. No bones have turned up alongside them, so nobody knows who was making them. Whoever it was not us. On Flores, 300 kilometers south, the picture is clearer and considerably stranger. In a cave called Liang Bua, excavators in 2003 found the skeleton of an adult woman who stood about a meter tall, with a brain roughly a third the size of ours, Homo floresiensis. Her species had been on that island a very long time. Stone tools attributable to them run from around 190,000 years down to about 50,000, and further inland at Matamenga, there are hominin fossils some 700,000 years old that appear to have been smaller still. In the Philippines, a foot bone recovered from Calao Cave in northern Luzon in 2007 and dated to 67,000 years turned out to belong to something else again. Homo luzonensis was described in 2019 from a dozen bones and teeth representing at least 3 individuals, small-bodied, with curved finger and toe bones, suggesting an animal that still spent real-time climbing. Elsewhere on the same island, there are butchered rhinoceros bones with cut marks and stone tools lying beside them at around 700,000 years. None of those islands has ever been attached to the mainland. Not Sulawesi, not Flores, not Luzon. Each of them sits behind deep water that has stayed deep through every glacial cycle for millions of years. Which means the crossing that took choosing a day and holding half a knot toward an invisible coast was not the first time something of the kind had been managed. Somebody had been getting over that water in one form or another for the better part of 1 million years. How? Nobody knows. No Pleistocene boat has ever been found because bamboo and rattan and hide do not last 50,000 years in a tropical climate, let alone 700,000. There are serious researchers who suspect tsunamis did the work. Involuntary voyages on rafts of storm debris, repeated across enough millennia that a few of them landed. There are equally serious researchers who regard that as a way of not saying the obvious thing. What can be said is that if you stand in front of that panel with a lamp, and you would need a lamp because it is well back in the dark, you are looking at work made by people who had come ashore on an island that already had somebody else living on it, or had until recently, and who were painting a hunt 15,000 years before anyone in Europe touched a cave wall. Whatever the standard account of when our species became recognizable to itself was built on, it was not built on this. The small people on Flores and whoever left the tools on Sulawesi were not the only other kind of human alive while that paint was going on. 4,000 kilometers north, in a cold valley in the Altai Mountains of southern Siberia, about as far from a tropical karst as it is possible to get, somebody had been leaving things behind in a cave for a very long time. It would be another 40,000 years before anyone noticed, and when they did, It arrived in the form of a single piece of finger bone roughly the size of a nail clipping. In a laboratory in Oxford, in 2016, a master's student named Samantha Brown was working through a collection of bone fragments from that cave. There were around 2,000 of them. None was larger than a few centimeters, most were smaller than a fingernail, and not one could be identified by looking at it. Excavation produces this material in enormous quantities. A cave floor occupied on and off for 250,000 years accumulates bone in bulk, and almost all of it ends up smashed. By the people eating it, by the animals that came in afterward, by the weight of everything piling up above. What comes out of the ground is chips. A good zoo archaeologist can identify a surprising number of them by eye, from the curve of a shaft or the grain of a surface. Below a certain size, nobody can, and those go into boxes, and the boxes go onto shelves, and generally that is the end of it. The technique Brown was using is called collagen fingerprinting. It works because collagen, the protein that gives bone its flexibility, survives far longer than DNA and differs very slightly from one species to the next. Take a few milligrams of bone powder, digest the collagen with an enzyme, run the resulting fragments through a mass spectrometer, and the pattern of masses that comes back is a signature. Check it against a reference library and it will tell you, quickly and cheaply, what animal you are holding. It cannot tell you which kind of human. It can only say hominin, which is one entry in that library among hundreds. So Brown worked through the collection sample by sample: horse, bison, deer, cave hyena, wolf, more deer, more horse. Somewhere around the 2000th fragment, one came back hominin. It was a piece of long bone about 2.5 centimeters long. It had been dug out of the East Gallery 4 years earlier, in 2012, and had gone into a box because there was nothing in it anybody could see. To understand why that mattered, it helps to go back another 8 years to a different piece of the same cave. In 2008, Russian excavators working under Anatoly Derevianko and Michael Shunkov recovered the tip of a finger bone from a layer in that same gallery. It had belonged to a girl of about 13. It was small enough to lose in a carpet. It went to Leipzig, to Svante Pääbo's laboratory, which was then more or less the only place in the world doing this work at scale, and it joined a queue of samples that were widely expected to turn out to be Neanderthal. In early 2010, Johannes Krause sequenced its mitochondrial DNA and got something nobody had prepared for. Modern human and Neanderthal mitochondrial sequences differ at roughly 200 positions. This one differed from modern humans at nearly 400, which put it outside both groups altogether, a lineage that had separated from the line leading to us and to the Neanderthals somewhere around 1 million years earlier and had continued independently the entire time. The nuclear genome followed later that year, and the population was given a name taken from the cave: Denisovans, which was, in its way, unprecedented. Every other kind of extinct human had been described from a skull, or a jaw, or a skeleton, from a shape somebody could hold up and argue over. The Denisovans were described from a sequence. Nobody had any idea what they looked like, and for another 9 years, nobody would. That genome carried a second surprise. Denisovan ancestry turned up in living people, and not in Siberians, where it might have been expected. It turned up in New Guinea and the islands east of it, at something like 4 to 6%. A population known from one fingertip in a cold Siberian valley had left a measurable inheritance 5,000 kilometers away in the tropics. Which brings us back to the fragment in the box. Once the collagen said hominin, it went for sequencing, and in 2018, Viviane Slon and her colleagues published the result. The specimen was female. She had been at least 13 when she died, judging from the thickness and structure of the bone. She lived around 90,000 years ago, and her genome was, in round terms, half Neanderthal and half Denisovan. On its own, that would not have been extraordinary. Populations mix, and a genome that is half one thing and half another is usually the product of many generations of gradual blending. What made this one different was how the halves were arranged. In a population that has been mixing for a long time, ancestry gets shuffled, short segments of each cut and recombined every time a genome is passed on. In this girl, the segments were long and unbroken. Chromosome by chromosome, one copy was Neanderthal and the other was Denisovan. Segments that long mean one generation rather than 50. What that arrangement describes is a mother and a father. The mitochondrial DNA, which travels only down the maternal line, was Neanderthal. So her mother was a Neanderthal woman and her father was a Denisovan man, and she remains the only first-generation offspring of two different kinds of human that anyone has ever found. There are further layers in it. Her father's own genome carried a small amount of Neanderthal ancestry from a much earlier encounter, several hundred generations before him, and her mother turned out to be more closely related to Neanderthals who lived later in Western Europe than to a Neanderthal recovered from the same cave thousands of years earlier, which means Neanderthal populations were moving back and forth across Eurasia during this period, and the cave was catching them as they came through. If you had met her, you would have seen none of this. You would have seen a girl of 13 in a cold valley in Siberia, doing whatever 13-year-olds did in a cold valley in Siberia 90,000 years ago. The categories that make her extraordinary are entirely ours. They did not exist for her or for either of her parents, and there is no evidence that anybody involved considered the arrangement worth remarking on. The authors were careful about what the finding did and did not establish, and the care is worth noticing. Turning up a first-generation individual among the very small number of archaic genomes ever sequenced, a couple of dozen at that point, implies statistically that mixing was common whenever the two groups occupied the same ground. The paper made that inference and stopped there. It did not extend the conclusion across Eurasia because Denisova Cave sits at the eastern edge of the Neanderthal range and near the western edge of the Denisovan one, which makes it the least random sampling location imaginable. Pabo's own summary was that the two probably mixed often when they met, and probably met rarely. The cave itself changed hands repeatedly. The layers record Neanderthals, then Denisovans, then Neanderthals again, across something like 200,000 years, and a good deal of that sequence has been read with no bones involved at all. DNA survives in cave dirt, waste, decomposed tissue, all of it leaves genetic material bound to the sediment, and it can be pulled out of a handful of soil. Entire populations are now detectable in the floor of a cave where nobody has ever found a body. Which is worth holding still for a moment. Two kinds of human separated for something like 400,000 years, distinct enough that we file them separately and argue about whether they were different species at all, and a girl who was simply the daughter of one of each. Whatever the boundary between them was, it does not appear to have been a boundary that anyone living inside it observed. Her bone fragment is in Leipzig, the fingertip, 3 or 4 teeth, and a few other pieces are the rest of it. That is the entire physical record of the Denisovans from this cave. 5 or 6 scraps, none larger than a thumbnail, all from a single valley in southern Siberia. Which leaves an awkward problem. The Denisovan ancestry sitting in living people did not come from these Denisovans. The population that left the most behind in the bodies of people alive tonight was only distantly related to the ones in this cave. They lived somewhere else for a long time, in numbers large enough to matter. Nobody has ever found one of them. So there is a population of human beings whose living descendants number in the billions and whose fossil record is empty. That is the strong version of the statement, and it needs one correction before it can stand. The Denisovan fossil record is not literally empty. It is simply so small and so tightly concentrated in a few places that it does not overlap with the populations that actually mattered, What exists amounts to a handful of pieces from 3 locations, and the entire physical record of a people who occupied most of Eastern Asia for several 100,000 years would fit comfortably inside a shoebox. The second of those locations is a cave at 3,280 meters on the northeastern rim of the Tibetan Plateau, above the town of Xiahe in Gansu province. You feel the altitude within a few hundred meters of the climb up from the valley. The air at that height carries around 2/3 of the oxygen it holds at sea level. Somebody arriving from lower ground gets a headache first, then finds any slope hard work, then undergoes a set of physiological adjustments that take weeks and never entirely compensate. It is a demanding place to keep a body running. In 1980, a Buddhist monk found a piece of jawbone in that cave. He passed it to a senior lama, who passed it to Lanzhou University, where it went into a drawer and stayed there for the better part of 40 years. When it was finally examined properly, no DNA could be recovered. The preservation was too poor for it. What could be recovered was protein. Collagen lasts longer than DNA, and its sequence, like DNA's, varies slightly between populations. The analysis returned a variant matching the Denisovan sequence from Siberia, and the carbonate crust on the surface of the bone dated to at least 160,000 years. It was the first Denisovan identified anywhere outside that one Siberian valley, 2,500 kilometers away, on a plateau where the air itself is a difficulty, which happened to explain something that had been sitting unexplained for 5 years. Modern Tibetans carry a variant of a gene called EPAS1, which governs how the body handles low oxygen. Most populations taken to altitude respond by manufacturing more red blood cells, thickening the blood and causing trouble over time. The Tibetan variant works differently. It keeps the blood thinner and manages the shortfall another way, and people carrying it live and work and raise families at 4,000 meters without much difficulty. In 2014, the variant was traced to its origin. It is Denisovan. It arrived through interbreeding, and it remains the clearest case anyone has of an archaic gene being kept because it solved a specific problem. The Denisovans had been up there long enough to adapt to it. Then they were gone, and the adaptation stayed, and it is currently keeping several million people comfortable at an elevation that would otherwise be marginal. Work at the same cave has filled the picture in since. Denisovan DNA has been pulled straight out of the sediment, with no bones involved, from layers around 100,000 and 60,000 years old. In 2024, a rib fragment was identified by the same collagen method, dating to somewhere between 48 and 32,000 years ago, and an analysis of more than 2,000 bone chips from the cave floor showed what they had been eating: blue sheep, wild yak, horses, birds, small mammals. They were not passing through. They lived there, across something like 130,000 years. The third place is not really a place, in the sense that nobody knows where it is. At some point in recent decades, a fishing trawler working the Penghu Channel, a shallow stretch of seabed about 25 kilometers off the west coast of Taiwan, brought up a human jawbone in its net. Trawlers there bring up fossils fairly often, because the channel is only 60 to 80 meters deep and spent every glacial period as dry land. The jaw went where such things go. It was sold, it passed through at least one antique shop, and a collector eventually bought it and donated it to a museum in Taichung. It was described in 2015 as an archaic human of uncertain type, heavily built, with unusually large teeth, plainly not modern. In April of 2025, protein analysis identified it. A Denisovan and the proteins preserved in the tooth enamel were specific enough to establish that he had been male. He came from a warm, humid, subtropical coastal plain at roughly the latitude of Havana. His nearest identified relative lived on a freezing plateau 3 kilometers up. The one before that lived in a Siberian valley with a hard continental winter. And the only reason anyone knows he existed is that a net came up with something in it and somebody decided it was worth keeping. None of those three, however, is the population that matters most. The highest concentration of Denisovan ancestry in any living people is not in Siberia or Tibet or Taiwan. It is in the Philippines, among the Aita Magbukon of Bataan, who carry around 52 megabases of Denisovan sequence per person, against about 42 in Papuans, who held the record until 2021. Once the more recent East Asian ancestry in the Aita Magbukon is accounted for, the gap widens to nearly half again as much as in Australians and Papuans. 52 megabases is roughly 1 part in 60 of a human genome. That is not a trace. It is a substantial, specific inheritance, and a good deal of it is functional. Immune genes, metabolic genes, the sort of material that gets retained because it does something useful. And when those segments are compared against the Siberian genome, they match at only about half. The population that contributed them was not the Siberian population. It was a relative, distant, separated for an extremely long time, living somewhere else entirely. What has emerged since is stranger again. Papuan genomes carry at least 2 deeply divergent Denisovan contributions, one of which appears to have split from the Siberian lineage around 360,000 years ago. Separate work identifies a third distinct event affecting mainland East Asians. So there were not Denisovans. There were Denisovan populations, plural, structured, divided from one another for longer than modern humans have existed as a species, spread across different parts of Asia and encountering incoming modern humans at different times in different places. We have bones from perhaps 2 of them, which raises a question worth asking honestly because the answer is not obvious. Is it fair to call these people a population at all? Population geneticists have a term for the situation. A group inferred entirely from its genetic contribution to other groups with no direct sample of its own is called a ghost population, and the Denisovans of island Southeast Asia are the largest and best supported one in the literature. The DNA is unambiguous. It can be measured, dated, and located within a genome. Almost nothing else can be said. Not what they looked like, not how they lived, not where their territory ended, not whether they would have regarded the Siberians as anything other than strangers. The name we use for them comes from a cave 2,500 kilometers from where any of them are likely to have lived, and refers to a group they had been separated from for longer than our own species has existed. There is a way of hearing that as a loss, and it is not quite one. Somewhere across island Southeast Asia, on Sulawesi perhaps, or Borneo, or a coastline that is no longer there were people for hundreds of thousands of years. They had bodies and children and difficulties. They worked out how to live in places we have not located. At some point they met the population coming down through the islands on rafts, and whatever happened between them happened often enough and successfully enough to leave 1 part in 60 of a genome behind. Everything of them above ground is gone. What survives is not in a museum drawer. It is in the immune systems of people in Bataan and in the highlands of New Guinea, doing the same work it was doing 100,000 years ago, inside bodies that are warm and asleep tonight. That is an unusual sort of monument, and it is not obviously a worse one. As for why nobody has found them, the likeliest answer has already come up once. Island Southeast Asia at low sea level was not islands. It was a peninsula the size of a continent, and nearly all of it, the coastal plains, the river valleys, the low ground where people actually live, went under when the ice let go. The bones are almost certainly where the rest of it is, which is a problem that repeats itself. Because the largest drowned country of all was not in the tropics. It lay in the north, between 2 continents, and for a very long time, nobody living on it had the slightest idea they were standing on a bridge. Look at the Bering Strait on a map, and it reads as a gap. 82 kilometers of cold water between Cape Desnev on the Russian side and Cape Prince of Wales on the American one, with two small islands sitting in the middle. On a clear day, each shore is visible from the other. It looks like a near miss. Two continents that almost touch and then decline to. Now take the water out. At the height of the last glacial period, with something like 120 meters of the world's ocean locked into ice, the strait stops being a strait. The seabed there is shallow, much of it under 50 meters, so what comes up is not a narrow causeway between two headlands. It runs 1,600 kilometers from north to south, longer than Britain end to end, and that is its width rather than its length. It also did not stand alone. Central Beringia was never glaciated, and neither was a great deal of the country on either side, so the exposed shelf joined continuously onto unglaciated Siberia in the west and unglaciated Alaska and Yukon in the east. Taken together, that region stretched something like 4,800 kilometers, from the Verkhoyansk Mountains in Russia to the Mackenzie River in Canada. Those are continental dimensions. That country stood above water for tens of thousands of years, and it lies today beneath the Bering and Chukchi seas. The second correction concerns what was growing on it. The picture most of us carry is ice, a white crossing, figures in furs moving briskly through a frozen waste. And the reality ran almost exactly opposite, for a reason that takes a moment to accept. Ice sheets need snow, snow needs moisture, and by the depth of the glaciation, so much of the planet's water was already sitting in ice that the interior of Beringia had gone very dry indeed, cold and arid means no glaciers. What grew there was grass. The ecosystem has a name, the Mammoth Steppe, and it was the most extensive single environment on Earth at the time, running from Spain across the whole width of northern Eurasia, over Beringia and into the Yukon. Dry grassland and herb tundra, productive enough to support very large grazing animals in very large numbers, woolly mammoth, steppe bison, horse, saiga antelope, muskox, and woolly rhinoceros at the western end of it. It is entirely gone, and it has no modern equivalent. The Arctic today is wet, bog, moss, stunted shrub, carrying a small fraction of the animal weight that country once did. Whatever combination of climate and grazing pressure and soil chemistry sustained the Mammoth Steppe has not occurred since, and there is a live argument among researchers about whether the grazers made the grassland or the grassland made the grazers. All of which brings the word bridge into focus as a genuine difficulty. The term is old. A version of the idea has been circulating since the 16th century, when a Spanish missionary reasoned that the peoples of the Americas must have walked there from Asia, and that some connection had therefore to have existed. The phrase itself hardened into the standard description during the 20th century, and it has been doing quiet damage ever since. A bridge is somewhere you are temporarily. It is narrow, it has a purpose, and that purpose belongs to the places at either end of it. Nobody lives on a bridge. The word carries every one of those implications, and the picture it generates, a file of people hurrying across a neck of land toward somewhere real, bears almost no relation to the evidence. What the evidence shows is that people stopped there. The genetics has firmed up considerably over the past 2 decades, and the shape of it is now reasonably clear. The population ancestral to every Native American separated from its East Asian relatives around 36,000 years ago, with some continued contact for another 11,000 years before that contact ended near 25,000. Within the same window, a second source contributed. A North Eurasian population, the same one that turns up in Ice Age Siberia. By 20,000 years ago, the group in Beringia had become genetically distinct from anything else alive. Then they stayed distinct, in place, for thousands of years. That isolation is what the literature calls the Beringian standstill, and its length is worth measuring against something familiar. If it ran even 5,000 years, which the estimates comfortably allow, that is around 200 generations, the same figure as everything human beings have ever written down, from the first accounts of grain in Mesopotamia to this evening. A population sat in one country, out of contact with the rest of the species, for as long as the entire subsequent history of writing. There is a grave in interior Alaska that makes this concrete. In 2013, excavators working a site in the Tanana Valley found a burial pit beneath an old hearth. Inside it were two infants laid together covered with red ochre, with grave goods set beside them, antler foreshafts, worked stone points. One was about 6 weeks old. The other had not been born. The burial is roughly 11,500 years old, and an earlier layer at the same site held a cremated 3-year-old. The site sits on the traditional lands of Tanana Athabascan people, and the local community named the children rather than leaving them as catalogue numbers. The 6-week-old is Zakiti Anen Tidegai, sunrise girl child. The unborn infant is dawn twilight girl child. The cremated child from the deeper layer is upward sun river mouth child. The tribal councils were involved throughout the research, which was a departure from how this work used to be done and is now increasingly the expectation. When Sunrise Girl Child's genome was sequenced and published in 2018, it turned out to be a population nobody had a sample of. She was not ancestral to modern Native Americans, and she was not a late offshoot of them either. She belonged to a group that had separated from the ancestors of everyone else in the Americas somewhere between 22 and 18,000 years ago, and had then remained in the north while the others went south. They are called the Ancient Beringians. She is the only good sample of them anyone has, which is the part that takes some adjusting to. Every version of the standard picture treats Beringia as a passage, somewhere people were in the middle of, on the way to somewhere that counted. For the population that produced that child, it was not a passage of any kind. It was simply where the family had been for longer than anyone could account for. If you had asked somebody there where they were from, the answer would have been the name of a river, or a stretch of shoreline, or a hill with something on top of it. It would not have been a direction. You can put a landscape around them without inventing much. Grass to the horizon, and past the horizon more of it. Herds large enough to change the sound of the air. Very long light in summer, and very little of it in winter. Rivers braided across gravel. Coastline in 2 directions, north and south, both of them rich, both of them now underwater. Almost no trees, and therefore bone and hide and driftwood for everything a person builds. Cold, dry, and, by the standards of the period, an extremely good place to be. Some of them did eventually go south, and their descendants are everywhere from Alaska to Tierra del Fuego. That is where the trouble starts, because there are only 2 plausible ways out of Beringia toward the rest of the Americas, and one of them was sealed by ice until far too late. The other has been lying under 120 meters of water for the last 10,000 years. So how did anybody get south? The question sounds straightforward and has resisted a settled answer for the better part of a century. Everyone agrees people were in Beringia. Everyone agrees their descendants ended up in Patagonia. The entire disagreement concerns the 6,000 kilometers in between, and a wall of ice that stood across the full width of the continent for a very long time. 2 separate ice masses covered North America at the height of the glaciation. The Laurentide, larger by an enormous margin, sat over Hudson Bay and spread across most of Canada and into the northern United States, and in places it stood 3 kilometers thick. The Cordilleran covered the western mountains, British Columbia, western Alberta, the southern Alaskan ranges. At the maximum, the two met and fused, and the combined sheet ran unbroken from the Arctic Ocean to the Pacific. Anyone standing in Beringia 20,000 years ago and looking south was looking at the edge of something with no visible end and no gap anywhere along a line 2,000 kilometers wide. The gap that eventually appeared is the one in every textbook diagram. As the two sheets began pulling apart, a lane opened between them, running roughly north to south along what is now the Alberta and British Columbia border, from the Yukon down into Montana, 1,500 kilometers long, with ice standing on both sides of it. That corridor was the standard answer for most of the 20th century. People came down it, reached the open plains, became the Clovis culture, and everything else in the Americas followed. It is a clean model. It fits the map, and it has been drawn as an arrow on very nearly every diagram of the peopling of the Americas ever printed. The difficulty is what was inside it. In 2016, a team led by Mikkel Winther Pedersen took sediment cores from lakes along the narrowest stretch of the corridor and read the DNA out of the mud. Lake sediment preserves genetic material shed by everything living in and around the water: pollen, plant tissue, animal waste, decomposed remains. Stacked in order, year by year, core it, date the layers, and you can reconstruct what was growing and walking there at any given moment. The answer was that for a long time after the ice let go, there was nothing. Steppe, vegetation, and with it bison and mammoth, appear around 12,600 years ago. Open forest with moose and elk at about 11,500. Full boreal forest by 10,000. Before 12,600, the corridor was open in the sense that ice was no longer physically in the way, and empty in every other sense that counts. It helps to picture what that means on the ground. When an ice sheet withdraws, it does not leave country behind. It leaves what was underneath it: bare rock and scraped up till, and colossal volumes of meltwater with nowhere to go, pooling into unstable lakes that drain catastrophically and refill. Nothing has had time to grow because there is no soil, and soil takes centuries. Set out to walk that 1,500 kilometers at 14,000 years ago, and you would be crossing gravel and mud and freezing water for months, in a wind coming off 2 ice sheets at once, with no game to hunt because there is no grass to feed any, nothing worth gathering, and the detail that decides the argument: nothing to burn, no wood, no dung, no peat. At that latitude, in that climate, a route with no fuel along it is not a hard route. It is not a route, which takes the corridor out as an entry path for anyone who arrived before roughly 12,500 years ago. It does not remove it altogether. Once it became viable, people certainly used it, and there is good evidence of movement northward through it later on. But the earliest arrivals did not come that way, because at the time they were arriving there was nothing in it that would have kept them alive. That leaves the coast. The coast is the road that works. It is also the one that cannot be excavated, having spent the last 10,000 years under 120 meters of seawater. The coastal model was put forward in 1979 by an archaeologist named Knut Fladmark, and then largely ignored for 2 decades, on the reasonable-sounding grounds that the corridor explanation already worked and nobody needed a second one. It was revived and sharpened in the 2000s by John Erlandson, who gave it the name it now carries. Kelp forests grow along the whole Pacific Rim wherever the water is cold enough and the bottom is rocky, from northern Japan up through the Kurils and the Aleutians, down the Alaskan and British Columbian coasts, past California, and eventually down the western edge of South America. They are among the most productive habitats anywhere on Earth. Fish, shellfish, urchins, sea otters, seals, seabirds, all of it concentrated into a narrow band along the shore. What matters for a moving population is that the band is continuous and it is the same band. A group that knew how to work a kelp coast in Kamchatka could work one in Oregon without learning anything new. There is no ecological wall to climb over, and travel by water along a shoreline is quick in a way that walking never is. A small craft with a current behind it covers more ground in a day than a family on foot manages in a week. Direct evidence is thin for the obvious reason, though it is not absent. Parts of that coast escaped glaciation even at the maximum, and bare bones from caves in southeast Alaska show large mammals living on those refugees while the surrounding country was buried. On Calvert Island in British Columbia, a team digging beneath the modern beach found 29 human footprints pressed into clay under the sand, adults and at least one child, around 13,000 years old. That stretch of coast has rebounded upward since the weight of ice came off it, which is the only reason those prints are reachable. Most of the route went the other way. The strongest inland support comes from western Idaho, where the lower Salmon River meets Rock Creek. The Nez Perce know the place as Nipehe. It was a village, and archaeologists call it Cooper's Ferry. Lauren Davis and his team have worked there for years, and the dates from the earliest occupation run between roughly 16,500 and 15,000 years ago, with a large tool assemblage securely placed around 15,800. That is 3,000 years before anything could have walked down the corridor. The tools matter as much as the dates. They are not Clovis points, they are stemmed points, a different technology with a narrowed base for hafting, belonging to what is called the Western stemmed tradition, and stemmed points of broadly comparable design turn up at Upper Paleolithic sites in northeastern Asia and Japan at similar and slightly earlier dates. The site also sits on water that runs to the sea. The salmon flows into the Snake into the Columbia, and the Columbia into the Pacific. Somebody coming ashore on that coast could follow water inland the entire way. Cooper's Ferry is accepted now by nearly everybody, including archaeologists who spent whole careers being very difficult to convince, which is where the honest summary has to sit, and it is not a comfortable place. The coastal route leads the field, and it leads in significant part by elimination. The corridor is ruled out by its own emptiness. The coast fits every date we have. It has a mechanism, it has kelp and boats, and a set of footprints on an uplifted beach in British Columbia. What it does not have is the thing that would settle it, a chain of coastal sites running down from Alaska with ages that get younger as they go. Those sites, if they exist, are offshore, underwater, beneath 10,000 years of marine sediment. Finding them is not impossible. It is enormously expensive, and for the most part, it has not been tried. Cooper's Ferry is about 16,000 years old, and for some years it was roughly as early as anyone was willing to defend in public. Then somebody looked properly at a set of footprints in a dry lakebed 1,500 kilometers to the south, and came back with a number 7,000 years older. The playa at White Sands only shows you the footprints when it is in the right mood. The ground there is gypsum, soft, white, and unusually responsive to water. When the surface is dry, the prints are invisible, because the gypsum bleaches to a uniform blank and everything on it disappears into everything else. When it is thoroughly wet, they flood and vanish under standing water. But in the window between, on a morning after rain when the flat is drying unevenly, the sediment inside a footprint holds its moisture slightly longer than the sediment around it, and the print rises out of the ground as a darker shape, sharp-edged and entire, for perhaps an hour. Then the flat dries the rest of the way, and it is gone again. The people who work there call them ghost tracks. If you want to see one, you have to be standing in the right place on the right morning, because nobody can summon them, and on the wrong morning you would walk across 100 of them without noticing a thing. There are a great many from more than one period, and this is worth being precise about, because it is easy to run them together. The set, made by the woman carrying a child, 3 kilometers of wet flat out and back with a giant sloth crossing behind her, sits in an upper horizon. It is somewhere in the region of 11 to 13,000 years old, bracketed by the megafauna that walked over it afterward, since mammoths and ground sloths supply an outside limit by the simple fact of having gone extinct. The prints that started the argument are not those. They lie lower in the sequence, along the margin of what was then a shallow lake, and they are a different proposition altogether. In September of 2021, a team led by Matthew Bennett published dates for them using radiocarbon on seeds. Growing in the shallows of that lake was an aquatic plant called Ruppia, ditchgrass, a submerged flowering plant that still grows in brackish water today. And its seeds were preserved in layers immediately above and immediately below the print horizons. Date the seeds underneath, and you have an age the prints cannot be older than. Date the seeds above, and you have an age they cannot be younger than. The prints sit inside the bracket. The bracket came out between 23,000 and 21,000 years ago, which placed people in southern New Mexico during the last glacial maximum, the coldest phase of the last ice age, with the 2 great ice sheets fused into a single mass across the top of the continent. At a moment when, on every model anyone was working from, nobody could have been south of them. The objection arrived almost immediately, and it was a good one. Ruppia is a submerged plant. It does not take its carbon from the air. It takes it from the water it grows in, as dissolved carbonate. And if that water has been moving through limestone, a substantial fraction of the dissolved carbon is extremely old. Limestone being made from the shells of animals that died hundreds of millions of years ago, with any radiocarbon in it long since decayed away. A plant drinking that water builds itself partly out of carbon that has no radiocarbon left. Date the plant, and the answer comes back older than the plant actually is. The effect is well documented and has a name, the hard water reservoir effect, and the Tularosa Basin sits in precisely the kind of carbonate country where it operates. Several researchers, including some who had spent decades working on early sites in the Americas, made the argument in print within months. What was at issue was the size of the offset. Some estimates put it in the hundreds of years, which would change nothing. Others put it in the thousands, which would change everything. The reply took 2 years and came at the problem from 2 directions, neither of which went anywhere near the lake water. The first was pollen. Pine pollen blows in from the surrounding hills and settles on a lake surface, and unlike a submerged plant, it takes its carbon from the atmosphere, which removes the reservoir problem entirely. The difficulty is quantity. A radiocarbon date needs a minimum of material, and a pollen grain is a few hundredths of a millimeter across. Jeff Pigatti and Kathleen Springer of the United States Geological Survey used flow cytometry to isolate pure pine pollen from the same sediment layers as the seeds, sorting grain from grain until there was enough to work with. A single date required something on the order of 75,000 grains. The pollen came back statistically indistinguishable from the seeds. 23 to 21,000 years. The second approach ignored organic material altogether. Optically stimulated luminescence on quartz from within the footprint-bearing sequence, the same technique applied to the sand in Arnhem Land, measuring how long since a grain last saw daylight. The burial ages overlapped the other 2. 3 methods resting on 3 unrelated physical principles, returning the same window. What the 2023 paper claimed is worth reading carefully, because it did not claim everything. The authors described their result as resolving the reservoir effect problem specifically. That was the objection they had been handed, and that was the objection they answered. They did not declare the site settled, and they laid out their stratigraphic reasoning at length, which is the standard courtesy of telling anyone who disagrees exactly where to push. People pushed. The remaining argument has nothing to do with chemistry now. It concerns which layer the dated material actually belongs to. If the pollen and the quartz came from sediment that had been reworked, eroded out of something older and redeposited around the prints, then the numbers are a ceiling rather than a measurement. The prints would be no older than 23,000 years, which is not at all the same as being 23,000 years old, and the real figure could be considerably younger. That objection is legitimate. It has not been fully retired, and further dating work has gone on returning results in the same range. If the dates hold, the consequence runs well past one site. It would mean people were living in the interior of North America at least 5,000 years before Cooper's Ferry and roughly 9,000 before there was grass in the corridor, during the glacial maximum, when the coastal route was at its hardest and the inland route did not exist. It would also mean something less comfortable. If people were in New Mexico 22,000 years ago, they ought to have been somewhere else as well, and the somewhere else has not turned up. There is no widely accepted site anywhere in the Americas across the 6,000 or 7,000 years that follow. That is a silence longer than the whole of recorded history, in a hemisphere that supposedly already had people living in it. There are three ordinary ways to take that. The population was small and mobile and left almost nothing, and we have not learned to recognize what it did leave, or the evidence exists and has been walked past, or the dates are wrong. There is a fourth, and it follows from something established much earlier in this story. Most attempts at going somewhere have failed. The people who walked out of Africa before 50,000 years ago left no descendants whatever, and their sites sit in the ground looking exactly like the sites of a successful colonization, because that is what a failure looks like from the outside. An arrival that did not take would appear from 22,000 years away as precisely this: a scatter of prints, no continuity afterward, and then nothing for a very long time. What is not in dispute is the prints. Whatever year they were made in, somebody made them. The 2021 study noticed something about who. The trackways at that lower horizon were left disproportionately by adolescents and children, the size distribution skewing young, the movement suggesting short repeated trips rather than journeys. The reading the authors offered is that teenagers were doing the fetching and carrying while adults worked at something in one spot. As reconstructions of the deep past go, it is an unusually ordinary one. Somebody sent the kids to go and get something. They are still out there, in a dry lakebed in New Mexico, surfacing for an hour at a time when the weather is right, and going back under. The argument about them is loud, and it is only 5 years old. It sits inside a much older argument, one that has been running for the better part of a century, that hardened at one point into something closer to a doctrine than a hypothesis, and that has cost a number of careful people a great deal more than a disputed date. In March of this year, a paper appeared in Science arguing that Monte Verde, the site that broke that argument open, the one everybody eventually agreed on, the one that has anchored the study of the peopling of the Americas for nearly 30 years, is about 9,000 years younger than anyone thought. Not marginally younger. The proposed range runs from roughly 8,200 years down to 4,200, against an accepted age of 14,500. If it holds, the foundation site of the modern account of the Americas is a mid-Holocene village, and a considerable amount of what has been built on it comes down with it. Within 2 months, around 30 researchers had published formal responses. One of them used the phrase, "egregiously poor geological work." Nothing is resolved. The dispute is, as of tonight, still going. To see why that matters, it helps to know what Monte Verde was for. In the late 1920s, excavators at a site near Folsom, New Mexico, found a stone point lodged between the ribs of an extinct bison, which settled a much older question about whether anyone had been in the Americas during the Ice Age at all. A few years later, at Blackwater Draw near the town of Clovis, larger fluted points turned up in deeper layers alongside Mammoth. The Clovis point is a distinctive object, a leaf-shaped blade with a channel struck up from the base on both faces, which is difficult to do and wasteful to attempt, since the flake removal snaps a fair proportion of otherwise finished points. They appear from Washington State to Florida, made to a strikingly consistent design, and the whole tradition seems to have lasted somewhere in the region of 450 years. Out of that came a model that held for most of the 20th century. Clovis was first. People came down the corridor between the ice sheets around 13,000 years ago, spread quickly, and everything in the hemisphere descends from them. It was coherent, it fitted the evidence then available, and it had the real virtue of being testable, since a claim about first arrival is falsified by finding something older. The difficulty was what happened when people tried. A standard of proof developed for pre-Clovis claims. Unambiguous artifacts, undisturbed stratigraphy, reliable dates, full publication. Every element of that is reasonable. There had been a long history of poor claims, natural stone breakage mistaken for tools, contaminated samples, sites where the geology had simply been misread, and skepticism was doing necessary work. What went wrong was sociological rather than logical. In practice, the standard drifted toward a position where no evidence was ever going to be enough, and the drift stayed invisible to the people doing it, because each individual objection remained defensible on its own terms. James Adovasio spent decades defending Meadowcroft Rock Shelter in Pennsylvania, where the lowest levels ran past 16,000 years, against a persistent argument that ancient coal in the groundwater had contaminated his radiocarbon. He is still defending it. Careers were consumed by this, and some were finished by it. The informal name the field used for the gatekeepers was not affectionate. Monteverde is what finally shifted it. The site sits on a small creek in southern Chile near Puerto Montt, and Tom Dillehay began work there in 1977. What made it extraordinary was preservation. A peat bog had formed over the occupation's surface, sealing it from oxygen, so organic material that normally rots away entirely survived. Wooden stakes, cordage of local reed still knotted, fragments of hide. The remains of a long tent-like structure on a wooden frame. Chewed seaweed carried up from a coast 30 kilometers away, several species of it medicinal. And a single human footprint pressed into clay beside a hearth. The date came out around 14,500 years, more than 1,000 years before Clovis, at the wrong end of two continents. In January of 1997, after 2 decades of dispute, a panel travelled to Chile to look at it. It included the field's most demanding skeptics. Among them, the man who had written the criteria pre-Clovis sites were being judged against. They went through the collections, walked the ground, and endorsed the date unanimously. That is usually described as the moment the old model ended, which makes the present situation an odd thing to hold. The site that closed one long argument by being carefully documented is now the subject of the next one for precisely the same reason. A site nobody publishes properly cannot be re-examined at all. The 2026 challenge, led by Todd Suravel with colleagues in Wyoming, Chile and Austria, does not dispute that people were at Monteverde. It disputes when, and it rests on 3 claims. The first is a layer of volcanic ash, about 11,000 years old, which they report finding stratigraphically beneath the archaeological material. And ash falls in a single event and settles as a layer, which makes it one of the most useful markers in geology. If it lies under the site is younger than it. The second is an erosional break in the sequence, indicating that time is missing. The third concerns the wood. Monteverde's dates come substantially from preserved wood, and the argument is that the creek carried older wood into younger deposits. Suravel's formulation is that dating wood at Monteverde does not date the occupation of Monteverde. Their conclusion is that the surface holding the material formed after around 8,600 years ago. The replies were published on the 13th of May in 3 separate letters carrying something like 30 signatures between them. Dillehaye's group states flatly that there is no 11,000-year-old ash layer beneath the site. Their position is that the samples came from between 50 and 400 meters away, taken from exposures along the edges of the drainage where the stratigraphy is discontinuous and does not correspond to the excavations, and that Suravel's team never dug inside the original site area, and so could not examine either its layering or the way its artifacts sat within it. Michael Waters, a geoarchaeologist at Texas A&M, was blunter. He observed that the paper describes one terrace as working simultaneously as an erosional and a depositional feature, which is not a thing a terrace can do, and that buried soils are plainly visible in the study's own published photographs and go unmentioned. His letter calls the work speculation and locates its worst failure in the mismatch between the stratigraphy described and the stratigraphy that is actually there. David Meltzer, who had been on the 1997 panel, offered the shortest form of the objection. The work was not done at the site. Suravel and his co-authors answered in June, defending their findings, with support from a number of other archaeologists, which is worth slowing down for, because the instinct is to read all of this as a science in trouble, and it is closer to the reverse. Set the two eras beside each other. The old consensus was enforced informally, in review panels and hiring committees and conference corridors, with objections unattributed and the costs carried privately by individual researchers across entire careers. What is happening now is loud, signed, specific and checkable. Every name is attached, every piece of reasoning is on the record, in a journal with photographs, and anyone who wants to can go and stand on the terraces and form their own view. A field that argues like this in the open is not a field failing. It is one where being wrong is survivable, which is the condition under which people will publish things that might turn out to be. The discipline has changed in another way since 1997, and it has nothing to do with stratigraphy. In July of 1996, 2 young men watching a hydroplane race on the Columbia River at Kennewick in Washington state found a skull in the shallows. The skeleton recovered from the bank was around 9,000 years old and very nearly complete. 5 tribes, the Umatilla, the Yakama, the Colville, the Wanapum and the Nez Perce, identified him as an ancestor and asked for his return. 8 scientists sued for the right to study him instead, and won. The litigation ran for the better part of 20 years. In 2015, his genome was sequenced, and the result carried no ambiguity. He was Native American, and of all living populations tested, he was closest to the Colville. The Corps of Engineers formally acknowledged it in 2016. Congress legislated his return that December, and on the 18th of February 2017, about 200 people from the 5 tribes buried him. They call him the Ancient One. The other case went differently. In 1968, on private land in Montana, a construction crew uncovered the only Clovis burial anyone has ever found. An infant laid down with more than 100 stone tools and antler rods and covered in red ochre, around 12,500 years old. When his genome was sequenced in 2014, federal repatriation law did not apply because the ground was private. The team consulted the surrounding tribes regardless, under no obligation to do so, and he was reburied that June in the Shields River Valley, in a ceremony held by several nations together. Both of those unfolded while the argument about dates went on around them, and at a certain depth, they are the same argument. What the Clovis debate was always about is who was here and when, and whose ancestors they were. And for most of the 20th century, that question got discussed as though nobody living had a stake in the answer. Monteverde today would not give you much to look at. A creek in wet country, a fenced enclosure, some signage. Somewhere underneath it is a hearth with a footprint beside it, left by a person who stood on soft clay for a moment and then walked on, and whose age is currently a matter of open dispute in the pages of a scientific journal. All of that argument is about when, which is what makes the next one strange, because there is a finding in South America where the dates are not in question at all, and nobody can explain how it got there. There is a piece of ancestry in the genomes of certain people in South America that has no accepted route into the continent, not a disputed route of the sort that has filled most of this story. No route. Nobody has put forward a voyage or a carrier population or a chain of coastal sites that survives contact with the evidence. The signal itself is real. It has been found repeatedly by separate teams using different methods on different samples, and it has now been sitting in the scientific literature for 11 years without an explanation anybody in the field is willing to defend in public. It was first described in July of 2015 by Pontus Skoglund and David Reich and their colleagues in a study comparing genome-wide data across 30 Native American populations. 3 groups in Brazil, the Surui and Caritiana in the Amazon, and the Savante on the Central Plateau, turned out to share more genetic variants with Australasian populations than any other Native Americans do. Australasian meaning, specifically, the Onge of the Andaman Islands, people from New Guinea, and Aboriginal Australians. The excess is small. Under most models, it comes to around 2% of the ancestry in the groups where it runs strongest, which is roughly the same magnitude as the Neanderthal inheritance carried by every European alive, a signal nobody has questioned in 15 years, small enough to have gone unnoticed for a long time, far too large to be noise. It is worth knowing how something like this gets detected, because the instinct that it must be a statistical accident is a perfectly reasonable instinct to have, and it does not survive examination. The test is not looking for Australasian DNA in the sense of finding a recognizable stretch of it sitting in somebody's chromosome. It works by comparison and by counting. Take 4 populations. 2 of them you have reason to believe are equally related to a third. 2 Native American groups, say, measured against a New Guinean. If that assumption holds, then at any position in the genome where the New Guinean carries a particular variant, the 2 American groups should share it with equal frequency, and across millions of positions, the deviations should be random and cancel out. What comes back instead, with the Surui on one side of the comparison, is a consistent lean. Position after position, right across the genome, they match the New Guinean slightly more often than they should. The imbalance is minute at any single site and very large in aggregate, and it does not disappear when you swap the populations or change the marker set or use data produced in a different laboratory. Reich's group gave the hypothetical source a name borrowed from Tupi, one of the major language families of Brazil. The word is Ipiquera, and it means ancestor. In the literature, it gets shortened to population Y. Put a globe in front of you and turn it until the Amazon basin and the island of New Guinea are both in view, and the problem stops being statistical and becomes physical. Those 2 places sit on opposite sides of the planet. Straight across the Pacific, it is something like 15,000 kilometers of open water with essentially nothing useful in between. Going the other way, up through Asia, across Beringia, down the length of 2 continents, it is nearer 30,000 kilometers of coastline. There is no short version of that journey. For 6 years, the finding sat roughly where it was, and the usual way of handling it was to observe that it turned up in a few isolated Amazonian groups, which might mean something unusual had happened in one corner of the continent and could be set aside. Then, in 2021, a team led from São Paulo with Tabita Hunemeyer and Marcos Castro e Silva went looking properly. 383 individuals from populations across South America, 438,000 genetic markers, and a systematic search rather than an incidental one. The signal is not confined to the Amazon at all. It appears on the Pacific coast of Peru among people associated with Chotuna in the Lambayeque region. It appears in the Guarani Kiowa, far to the south. It is spread across a substantial part of the continent, running strongest in the populations that have stayed most isolated and faintest in those that have mixed most, which is precisely the pattern something old and progressively diluted would leave. The São Paulo team's reading is that the ancestry came down the Pacific coast with the earliest arrivals and worked inland from there. That accounts tidily for the distribution. It does not go anywhere near the question of how Australasian-related ancestry reached the Pacific coast of the Americas in the first place. One possibility could be eliminated quickly, and was, if the signal had arrived recently through Pacific labor migration in the 19th century, for instance. It would be absent from ancient remains. It is not absent. It has been detected in the genome of a person from Lagoa Santa in Brazil who died around 10,400 years ago. Whatever this is, it was already in South America before anyone anywhere on Earth had planted a crop. That leaves 3 ways of accounting for it, and none of them works. The first is a direct crossing of the Pacific. Somebody sailed from Australasia to South America very early and left descendants. Against this sits 15,000 kilometers of ocean with no useful stepping stones at that latitude, no shared material culture, no linguistic connection, no boats, and a date that places the crossing tens of thousands of years before anything comparable was attempted anywhere on the planet. It is not quite impossible. It is close. The second is that the ancestry traveled through Beringia, carried by some fraction of the people who founded the American populations. This is far more plausible, and it is where most researchers lean. The difficulty is that it then has to have come from somewhere in Asia, and no Asian population, living or ancient sampled anywhere, carries it in the right form. Not in Siberia, not among the ancient Beringians, not in the East Asian genomes sequenced so far. If such a population existed and passed through, it has left no other trace of itself anywhere on Earth, which is a familiar shape by now. It is another ghost, a group inferred entirely from what it left inside somebody else, with no sample of its own and no address. The same problem standing behind the Denisovan inheritance in the Philippines has reappeared on the opposite side of the Pacific in a different kind of evidence, at a different depth. The third possibility is that the signal is an artifact, that it emerges from unmodeled ancient structure in the reference populations rather than from any real migration at all. That has been argued seriously, and it is a large part of why the finding is not shouted about more. But it has been tested by independent groups, with independent samples, using independent methods, for over a decade, and it keeps coming back. So the honest summary is short and slightly uncomfortable. Something contributed ancestry to the people who became South Americans, and that something was more closely related to Australasians than to any population presently known from either Asia or the Americas. It did so early. It has left no bones, no site, no tool, no language, and no name. It exists as a persistent faint lean in a statistical comparison, running across millions of positions in the genomes of people who are alive tonight and have no idea it is in them. That is the entirety of it. 11 years, several independent confirmations, a much better map of where the signal sits, and not one accepted proposal for how it got there. There is a particular relief in a question shaped like that. Most of the arguments in this story are arguments about numbers, whether a date is 65,000 or 50, whether a layer of ash lies above a floor or below it. They are resolvable in principle, and most of them will eventually be resolved. This one is not yet even the right shape to take sides on. Nobody is fighting about population Y, because there is nothing to fight about. What the signal does wherever it originated is point west. Every one of its relatives, the Andamans, New Guinea, Australia, sits on the far side of the largest body of water on the planet. And out in the middle of that water, several thousand years later, and connected to none of this, people were about to begin doing something that has never been fully explained either. There were still, at that point, several thousand islands that nobody had ever stood on. Pick up a broken piece of Lapita pottery, and the first thing you notice is how it was decorated. The potter did not paint it or carve it. They took a small tool with teeth cut along one edge, comb-like, made from shell or bone or hardwood, and pressed it into the clay while it was still soft again and again, building the impressions into dense, repeating bands. Zigzags, triangles, hatched panels, and on some vessels a stylized face with two eyes looking out of the ornament. The technique is called dentate stamping. If you tried it yourself, you would find the difficulty is not the pressing, but the planning, because the whole design has to be held in the head and assembled from several hundred separate impressions, and a mistake cannot be undone. Now widen the frame. That style of decoration, not a similar style, that one, with the same vocabulary of motifs and the same rules about how they combine, turns up on pottery from the islands off northeastern New Guinea all the way east to Tonga and Samoa. 4,500 kilometers of open Pacific, and the whole spread took somewhere in the region of 400 to 500 years. That expansion is worth setting against what came before it, because what came before it was a very long pause. People reached New Guinea and the islands immediately around it early. The Bismarck Archipelago by roughly 35,000 years ago, the main Solomon Islands chain by 29,000. Then they stopped and stayed stopped for something on the order of 25,000 years. The line they stopped at has a name. Everything up to and including the main Solomons is near Oceania. Everything past it, Vanuatu, New Caledonia, Fiji, Tonga, Samoa, and every island east of those is remote Oceania, and until about 3,000 years ago, no human being had ever set foot on any of it. The difference is not really distance, though the gaps do widen. Near Oceania is close enough to a continent to function as an extension of one. Its islands are large, they are visible from each other, and they carry the plants and animals of New Guinea. Remote Oceania is properly oceanic. The islands are small and widely separated. The land biota thins to almost nothing, and on most of them there is very little a person could eat on arrival. What crossed that line arrived equipped. Lapita sites appear in the Bismarcks around 3,300 years ago, reach Vanuatu, New Caledonia and Fiji within 3 centuries, and reach Tonga and Samoa a century or so after that. The voyagers carried pigs, dogs and chickens, taro, yam, breadfruit, banana, coconut and sugarcane, pottery, shell adzes, fishhooks, ornaments, and, without intending to, the Pacific rat, several species of snail and a number of lizards. That is not exploration, it is a colonizing system, packed and repeated. Arriving on an island with no edible land animals and a handful of unfamiliar plants is survivable only if the ecosystem comes with you, and theirs did, island after island, across 4,500 kilometers. They also stayed in contact. Obsidian from a single source at Talisea, on the north coast of New Britain, has been recovered from Lapita sites more than 3,000 kilometers to the east. Volcanic glass from one quarry carried the length of the expansion. The boats went back as well as forward. The best evidence for who these people actually were came out of the ground in 2004 on the island of Ifate in central Vanuatu, when a bulldozer clearing land for a prawn farm cut into a cemetery. Tiuma is the oldest burial ground in the Pacific, around 3,000 years old and close to the leading edge of the expansion. Something like 68 burials have been excavated, and the mortuary practice was specific and consistent. The dead were buried, and then, once the body had decomposed, the skull was removed and taken somewhere else. Most of the adults at Tiuma are headless. In one grave, an adult man had been laid out with 3 skulls placed in a row across his chest. There was also a lapita pot used as a burial vessel, with 4 birds modelled around the rim, facing inward toward whatever it held. In 2016, and then more completely in 2018 and 2020, ancient DNA was recovered from Tiuma and from comparable early sites in Tonga, and the results were not what anyone had assumed. The expectation had been that lapita was a blended movement, Austronesian-speaking people out of island Southeast Asia who had travelled through New Guinea and the Bismarcks, taking on ancestry from populations that had been there for tens of thousands of years and carrying that mixture east. The earliest settlers of remote Oceania carried almost no Papuan ancestry whatsoever. The Tiuma individuals come out somewhere between about 0.1% and just under 5%, which at the low end is nothing and at the high end is very little. However they had managed it, they had moved through near Oceania without mixing much with anybody living there. Then, beginning around 2,500 years ago, within a few centuries of the founding, Papuan ancestry starts arriving in remote Oceania and steadily increasing. The populations of Vanuatu today carry predominantly Papuan ancestry, and what the founders contributed is now the minority component. The languages did not change. There are over 130 languages spoken across Vanuatu, the highest density of distinct languages per head of population anywhere on Earth, and with a small handful of exceptions, everyone is Austronesian. They descend from the speech the first settlers brought with them. The later arrivals, whose ancestry now predominates, either did not bring their languages or brought them and put them down. So the words being spoken across those islands this evening are the words of a founding population whose genetic contribution has since been substantially diluted. The sentences outlasted the lineage. The term that got used for this in the first round of coverage was replacement, and it needs handling carefully because it invites a picture the evidence does not support. The archaeologists who had spent decades working those sites said so at the time, in print, and there was a real exchange between them and the genetics teams about how the findings were being described. What the later and better sampled work established is that none of this was an event. It was incremental, arrivals across centuries in several distinct pulses, ordinary intermarriage over many generations, in a region where people were already travelling back and forth along established routes. Nobody was displaced. Nobody disappeared. The people of Vanuatu are the descendants of both streams carrying more of one than the other, which leaves a question that is genuinely difficult and better sat with than settled. We tend to treat ancestry as the deep fact about a people and culture as the surface, the layer that can be adopted or dropped, laid over the real inheritance underneath. Vanuatu turns that upside down. Asked which of the two things the founders passed on more durably, the honest answer is the language. 3,000 years on, the genes have been thoroughly rearranged and the grammar has not. So which one is the inheritance? The material that gets shuffled and recombined every single generation and can now be measured to 2 decimal places, or the sound a child learns before they can walk, handed mouth to mouth across 150 generations without a break. There is no obvious reason the first should count for more beyond the fact that we have recently worked out how to measure it. They reached Tonga and Samoa around 2,800 years ago, at the eastern edge of everything then known, having crossed 4,500 kilometers of ocean in under 5 centuries, and having demonstrated fairly comprehensively that they could go wherever they chose to go. Ahead of them lay the rest of the Pacific: Hawaii, Aotearoa, Rapa Nui, the Marquesas, the Tuamotus, several thousand islands, not one of them occupied by anybody. They stopped and did not move east again for 2,000 years. Nobody knows why. That is the honest place to begin, and it is worth saying plainly before the explanations start, because the explanations are all reasonable and not one of them has been established. A population demonstrably able to cross 4,500 kilometers of open ocean, in possession of the boats and the food plants and the seamanship required to do it, arrived at the eastern margin of everything anyone had ever seen, and stayed there. The pause is not a small irregularity in the record. It ran 4 times longer than the expansion that produced it, and about as long as the whole period from the beginning of the Common Era to this evening. Then, on the far side of it, the remaining distance was crossed, and the largest empty space on the planet was filled inside 2 centuries. What lay east was not a handful of further islands. The triangle with Hawaii at its northern corner, Aotearoa in the southwest, and Rapa Nui in the east covers something in the region of 25 million square kilometers. Take New Zealand out of it, and the land in all the rest amounts to roughly 1 part in 1,000 of the water. Finding anything in that requires a precision which is difficult to convey in ordinary terms. If the Pacific were a dinner plate on the table in front of you, Rapa Nui would be a single grain of salt somewhere on it. 4 explanations circulate, and they are not mutually exclusive. The first is the boats. There is a genuine difference between the craft that carried Lapita east and the double-hulled voyaging canoe of the later expansion, larger, faster, and rigged so as to make real progress into the wind. That matters more than it may sound, because the trades across the tropical Pacific blow from the east. Going east means going to windward for weeks, with nothing to stop at. The pause may simply have been the time it took to build a vessel that could do that dependably, and to develop the seamanship to go with it. The second is the wind itself. Paleoclimate reconstructions have identified periods when the ordinary pattern broke down and sustained westerlies ran across the region, during strong El Niño phases and during a longer climatic anomaly centered on the medieval period. Modeling those windows suggests that voyages, which would normally have been punishing, became straightforward for a few decades at a stretch. On this reading, the pause ended because the weather changed. The third is drought. Records from the southwestern tropical Pacific indicate a severe dry period, running from roughly the 9th century into the 13th, overlapping the expansion almost exactly. If home was becoming harder to live on, that is reason enough to leave, and it requires nothing new about the boats at all. The fourth is social. Populations grow, land subdivides, younger sons and their households find themselves without inheritance, and competition between chiefs rewards whoever comes back with something nobody else has. It is the least romantic explanation, quite possibly the most likely and very nearly impossible to test. None of them is established. Several may be partly right at once, which is the usual condition of things that happened 3,000 years ago and left no account of themselves. What can be said is that around 1,000 years ago, and then very quickly, people went, reaching the Society Islands, the Marquesas, Hawaii, Rapa Nui, and Aotearoa, and completing the occupation of the last habitable land on Earth within a couple of centuries. For a long time, there was an argument about whether they had meant any of it. The strongest version of the skeptical case was published in 1956 by a New Zealand civil servant named Andrew Sharp, who held that Polynesians could not have navigated accurately across those distances, and that the settlement of the Pacific was the accumulated residue of accidents, canoes blown off course, arriving somewhere by chance, unable to find their way back or report what they had found. The argument had reach. It was taught in universities for 2 decades, and it was received across the Pacific roughly as you would expect an argument to be received, which says that a people's greatest achievement was something that happened to them. By the 1970s, the case had been damaged academically. Computer simulations of drift voyages, run in 1973, showed that accident could not deliver anybody to Hawaii or Rapa Nui or New Zealand at all. But the demonstration that mattered did not take place in a journal. In 1973, a group in Honolulu, an artist, an anthropologist, and a waterman, founded the Polynesian Voyaging Society and set about building a canoe. Not a replica of a surviving vessel, since none survived, but a reconstruction assembled out of 18th century European ship drawings, oral accounts, and a great deal of argument. 62 feet, 2 hulls, 2 crab claw sails. She was launched in March of 1975 and named Hokulea, the Hawaiian name for the star Arcturus. It means Star of Gladness. It is the star that passes directly overhead at Hawaii, the one that tells a navigator coming north that he has reached the right latitude and can turn. The difficulty was that nobody in Hawaii knew how to navigate. That knowledge had been gone for generations, broken by 2 centuries of colonization and missionary schooling, and the plain fact that a practice which stops being practiced stops being handed on. There was no one left in Polynesia who had been trained to do it. There was one man in Micronesia. Mau Piailug was born in 1932 on Satawal, an atoll about 1.5 miles long in the Caroline Islands. His grandfather started teaching him at 5, and he was initiated as a master navigator at 18. He held the star compass in memory, the rising and setting points of some 30 stars around the horizon, arranged as a mental chart, with the canoe imagined motionless and the islands moving past it. He read swell patterns through the hull with his own body. He could infer position from the behavior of birds, from the shape of cloud standing over land beyond the horizon, from the interference where a swell wrapped around an island he could not see. He agreed to navigate for reasons of his own. The tradition was failing on Satawal too. He had watched younger men lose interest in it, and he took the view that if Hawaiians wanted it back, it was better held somewhere than nowhere. The canoe left Honolulu Bay on Maui on the 1st of May 1976, with no chart, no compass, no sextant, and no radio navigation of any kind. Mau steered by the stars at night and the sun and the swells by day, correcting continuously for a current he could feel and could not measure, across 4,000 kilometers of open ocean toward an island group he had never visited. 34 days later, the canoe came into the harbor at Papeete. More than 17,000 people were waiting on the beach. Over half the population of the island had come down to the water. Nobody had organized a reception on that scale, and the arrival could not have been announced with any precision because there was no way for anyone aboard to send a message. People had simply been watching for it. Word went around, and when the sails came up over the horizon, the beach filled. It is worth being careful about what that proved, because the temptation is to let it carry more than it can. It proved capability, completely and in public. A navigator working from nothing but memory and attention can cross 4,000 kilometers of open water and make his landfall, and whatever else remains arguable about the peopling of the Pacific. Accidental drift is no longer part of the conversation. It did not prove motive. Mau knew where he was going and why. He had a destination on charts other people had made, a crew who had volunteered, and a reason. The people who found Rapa Nui had none of those things. They left the last land they knew, and sailed east into an ocean where the nearest object they would meet, if they met anything at all, was a volcanic island 24 kilometers long, 2,000 kilometers from its closest inhabited neighbor. Why anybody did that is not a question a canoe can answer, and it is still open. They found it regardless, somewhere around the 13th century, and what followed has been badly served by the popular account. For decades, Rapa Nui was told as a parable, a society that consumed its own environment, felled its last tree, and collapsed into starvation and violence before Europeans arrived to find the wreckage. The story has been used to illustrate a great many arguments about the modern world. In September of 2024, a team working in collaboration with the Rapa Nui community published the genomes of 15 people who lived on the island between roughly 1670 and 1950. The genetic record shows a population growing steadily from the 13th century straight through to European contact. There is no collapse in it. Whatever else was happening on that island, the demographic catastrophe the parable requires did not take place. The same genomes carried something further. Around a tenth of the ancestry is Native American, and it entered the population between roughly 1250 and 1430, well before any European ship reached the Pacific. Somewhere inside that window, people from Rapa Nui and people from South America met, and the meeting left children. Which direction the boat was traveling cannot currently be established. One place was left. Madagascar sits 400 kilometers off the coast of Africa and was permanently settled somewhere between the 8th and 13th centuries, which is astonishingly late for an island that large so close to an inhabited continent. The people who settled it did not come from Africa. The Malagasy language is Austronesian, and its nearest relatives are spoken in the southeast of Borneo, 7,500 kilometers away across the Indian Ocean. Modeling of the maternal lineages points to a founding group of around 30 women. They passed the entire coast of India and Arabia and East Africa to arrive there. And with that, it was done. Every habitable coastline on the planet had somebody living on it, and a process that began with a family camping 10 kilometers further up the valley than their parents had run itself out. Nobody at any point had been carrying out a plan. There was no plan. There was demography, and weather, and boats, and the ordinary human disinclination to stay somewhere that has stopped working. There is something worth sitting with in how little of this is understood. Not one of the large questions in this story has been settled. We cannot say when people reached Australia within 20,000 years. We cannot say how anyone got south of the ice in the Americas, or whether the earliest arrivals left descendants at all. We do not know where the Denisovans lived or what they looked like, though a great many people are carrying them. Nobody can explain how an Australasian signal reached the Amazon. We cannot say why the Pacific was crossed when it was crossed, rather than 2,000 years earlier. That is an unusual quantity of ignorance about the largest thing our species has ever done, and it is worth being clear about where it comes from. It is not carelessness. It is that the coastlines people actually lived on are underwater, that bone does not last in the tropics, and that almost everything a human being does leaves nothing behind whatsoever. A person can live 70 years, raise children, learn a coast, name a river, and pass out of the record completely, having left less trace than one footprint in the right kind of mud. And what we hold, sitting with that, is not really loss. It is nearer to recognition, because the people doing the walking did not know either. Not one of them knew where they were going, or that they were going anywhere, or how any of it would come out. They went on the evidence available, which was thin, and they were mostly wrong about what lay ahead, and it worked anyway. Not knowing has been the condition of this. From the very beginning, it has never once stopped anybody. Which brings it back to New Mexico. The flat at White Sands is quiet nearly all of the time. A gypsum basin with almost nothing growing on it, ringed by mountains, white and dry for most of the year, with a wind that crosses it and finds nothing to catch on. After rain, for a little while, the ground remembers. The prints come up out of the surface as the water goes, darker where the sediment inside them holds its moisture a fraction longer than the sediment around. A line of them heading north. She has the child up by this point. The weight has settled onto one hip, and the prints on that side press deeper. Further along she moves the child across, and the depth shifts to the other foot. Somewhere at the far end she set the child down. On the way back there are only her own prints. They are lighter, and there is nothing in them to suggest anything went wrong. You could stand in one of them. They are not big. Nobody knows her name, or the child's, or where they were going, or what the errand was, and nobody ever will. It matters less than it might. What she was doing that afternoon was not the kind of thing that gets remembered. She was moving a child from one place to another place a couple of kilometers away, because that was what the day required. 2,600 generations of people did more or less that, on every coastline on Earth. One of the results is that you are lying down tonight, warm, indoors, at the far end of the line. The ground dries, the prints close over. They have been surfacing and closing like that for 11,000 years. They will go on doing it after tonight, whether anybody is standing there or not. None of this is finished. The walking never stopped. It only became quieter and slower and turned into other things, into ships and roads and the ordinary business of moving house. But it is the same motion, and it is still going on, and it will still be going on in the morning. There is nothing left to do about any of it this evening. Set it down. Rest now. Sleep well.